welcome our Academic Director, Dr. G. Samsivarao Garu, onto the dais. Your strategic vision and commitment to quality of education have been pivotal to our success. Dr. D. Kailasrao Garu, onto the dais. We are delighted to have with us our chief guest, Dr. K. Venkat Reddy sir. Sir, please come on to the dais and occupy the seat. Your presence today adds a great value to this occasion and we look forward to your inspiring role. Now I would like to invite Dean of CSE, Dr. and Director of R&D, Dr. Samsivarao sir, to please come on to dais and please occupy the seat. Last but not the least, I welcome all the participants who came all the way to attend a 2-week ACT sponsored ATAL FDP. Now, as in our tradition, let us proceed with the ceremonial lighting of the lamp.
Ya kundetu tusharharadhavana, ya shubhravastravruta, ya veena-varadandavandita-kara, ya shveta-padmasana, या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा.
We will have a prayer song to invoke blessings and ensure a harmonious start to our program. I invite Soumya Deepthi, Srikala and Roshmi of 3rd Triple E to lead us in the prayer song.
गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलत्थायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्मसदाराध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डकण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि.
Now I request Coordinator of ATAL FDP, Head of Triple E Department and Controller of Examinations, Dr. N. Samsivarao sir, to give a welcome address.
Honorable Chairman, Sir, NRI Group of Colleges, Dr. R. Venkat Reddy sir. Chief guest of the program, Dr. K. Venkat Reddy sir, Professor and Head of the Department of Renewable, and former Director Academic Planning, DAP, and former Controller of Examinations, JNTUK KAKINADA, and respected Principal sir, Dr. Nagabhaskar sir, and respected Director Academics, Dr. G. Sambasivarao sir, former Principal, VR Siddhartha and Elur C.R. Reddy Engineering College, and Dr. G. Rose sir, not there sir, and respected Dean R&D, Dr. K.V. Sambasivarao sir, and respected Academic Coordinator, Dr. D. Kailasarao sir, and all the deans and heads of the department, a very good morning to one and all, and welcome to ACTE sponsored 2-week faculty development program on artificial intelligence based energy storage system integrated with renewable and sustainable energy sources for electrical vehicles. This faculty development program is sponsored by ACTE Training and Learning Academy, ATAL Academy, which is scheduled for 2 weeks from 2nd December to 14th December, which is scheduled for 14 sessions in offline mode and 8 sessions in industrial visits. The objective of this faculty development program is providing sound knowledge in electrical vehicles, including AI techniques in energy storage system, battery management system, and the integration of the renewable and sustainable energy sources. I request all the participants to avail this opportunity and gain in-depth knowledge in electrical vehicles. Regarding our department, in NRI Institute of Technology, our Department of EEE started in the year 2008 as a BTech EEE UC program and Master's program MTech with a specialization of Power Electronics and Drives was introduced in the year 2013, and our department is accredited by NBA twice, and we have approved research center by JNTUK KAKINADA. With this, I especially thank to ACTE, ATAL Academy, and especially our Honorable Chairman Sir for this opportunity, and I thank to our Chief Guest of the program, Dr. K. Venkat Reddy Sir, for accepting our request, and also thank all the participants for attending this faculty development program. Thank you one and all.
Thank you, sir. Now I request Dr. C. Nagabhaskar Garu, Principal, NRI Institute of Technology, to address the gathering.
Dignitaries on the dais, the chief guest for today's function, and a resource person for this day one, Professor K. Venkat Reddy sir, and our academic director, Professor Sambasivarao Garu, and coordinator of this program, N. Sambasivarao Garu, our academic coordinator, Kailasarao Garu, R&D director, Professor K. V. Sambasivarao Garu, other head of the departments, placement director, faculty members of EEE department and other departments, and particularly participants, a very good morning to one and all. At the outset, first of all, I would like to thank the K.V. Venkat Reddy Garu for attending this program and accepting our invitation as the chief guest for today's program. Actually, he is having a very tight schedule. Yesterday also I know that he is attending faculty interviews, ratification interviews, and to other programs he is working as a guest of honor and chief guest and a resource person. And apart from his schedule in JNTU, thank you very much sir for attending your out of busy schedule to our institution. Personally, I know him very well because earlier he worked as a director of academic planning and also control of examinations. Particularly, I had a very good interaction with him during the COVID time. Really, COVID time, conducting the examinations and releasing the results on time is a very challenging task because it is the first of its kind. We never had such a better experience earlier. But in such a critical situation, he handled very well. He conducted all the examinations successfully and also results were released in time. Very congratulations for doing such a wonderful job at that time, sir. And similarly, after becoming a DAP also, the government took a strict decision that all the autonomous colleges should implement only JNTUK curriculum like that. But at that time also, we principals, we approached him, requesting him to give some liberty for us in curriculum design and all. He understood the concerns of all the principals and he has given 20% of the liberty in designing the autonomous colleges. Like that, in many situations, he is a very good at heart, but he seems to be very tough regarding the rules and regulations. But many times, for many colleges, he helped in many ways. Sir, we remember you always, sir. And certainly we believe that in the coming days, you are going to occupy highest positions in the university, sir. Very nice, sir. So for the sake of the information of the chief guest and other participants, just I would like to mention that, sir, our institution was established in the year 2008 with 4 branches and 240 students. Sir, after completing a journey of 15 years, today we are having 10 UG branches, 6 PG branches, and nearly 5,000 plus students are there in our institution. I am very happy and proud also to announce that, sir, apart from our contemporary colleges and already senior colleges, sir, now in the Krishna district we are occupying the 2nd position in the admissions, getting the highest admissions in the institution, sir. Sir, we are having NBA accreditation for above 90% of the departments who are eligible departments, and who are accredited by NAAC twice, sir. And apart from that, we have many awards and recognitions by prestigious institutions. Sir, every year, very proudly we announce that we are getting 85 to 90% of the placements in the, that also we are occupying 2nd position in the Krishna district, sir. Apart from that, our institution is having 4 research centers recognized by the JNTUK KAKINADA, and we are having 7 Center of Excellences in our institution, and also we are having an incubation center of MSME. And right now we are having, sir, nearly 56 to 60 working MOEs with our institution with nearby industries and reputed education institutions, sir. Sir, coming to EEE department, as sir already mentioned, I can say that EEE department is one of the departments who always stands in the first row along with the other departments in almost all the incidents that we conduct in academics, in conducting the programs, in students' discipline. In all the times, this EEE department is one of the departments which stands in the first row along with the other departments. Sir, coming to present FDP program, I really congratulate the coordinator for selecting such a very nice topic, and it is a very apt time to select such a nice topic because nowadays these electrical vehicles are gaining a lot of importance. Further, the reason is that there are many problems with the conventional fuel engines, that may be emissions point of view or pollution point of view. Okay, but electric vehicles have gained a lot of momentum because of this. Now these electrical vehicles are running by using a battery. How that battery is going to be charged? Again by the electric power that is generated by grid. That means suppose if thermal power station is generating electric power, and if that power again you are using for the automobiles, I think it doesn't serve that much purpose. It is also not environmentally good because again that thermal power station is generating and emitting a lot of emissions to the atmosphere. So instead of that, to charge this battery, if you have any other alternative source, that means by using any renewable energy or by using any other sort of non-conventional energies to charge that battery, that would be a very good. That means, suppose once you have charged the battery, when you are running the vehicle,
Then if you want to charge the battery, one way is you can use the solar panels above your vehicle, and that solar energy by using that can be converted to electrical energy, and that energy you can use for charging the battery. That is the one way. And one more thing, when your vehicle is going on, in our conventional vehicles, in the radiator place, if you keep any small fan like that, and vehicle is moving it forward, if that fan is rotating, I don't know to what extent it is possible, if that fan is rotating, that fan may generate some electric power. That power may be a fraction. That power also we can use for charging the battery again. So like that, whenever you apply the brakes, heat energy generated, mechanical energy will be wasted. Why cannot we use that energy also for converting into a useful energy and for again charging the battery? Like that, there is no limit for ideas. Like that, if you think in the right direction, you may get many innovation ideas, and for charging the battery by using the sustainable and non-renewable energy. So really I am congratulating Samsara Garu for selecting a right topic in the right time. Next. So coming to participants, I really congratulate the participants. I know how hard it is to get a permission from the principal for attending the workshop for 2 weeks. Really it is a challenging task. No principal rightly give the first instance itself permission, because he will have a lot of academic work in his department. So no management readily sanction the permission. In spite of that, you have got the permission and you are attending for this program. Really I am congratulating every one of you, and I am also confident that this FDP is going to throw light onto many useful topics for you. And at the end of this program, I am confident that along with your certificate, you are going to carry a useful information along with you. I am very confident of it. And one more thing, particularly for core branches, electrical, civil, mechanical, nowadays facing a very hard test. In many institutions, these departments are getting closed, or otherwise the strength is reducing. And recently, I saw in the newspapers also, in Hyderabad, some of the faculty members relating to these core departments are working as a salespersons or something like that. Really, it is a very, very unfortunate situation. Many faculty members completing their BTech, electrical, BTech and MTech and PhD also in electrical engineering, and all of a sudden, if there is no job, where they will go? Even then, how suddenly they will convert their field from electrical or core engineering to computer science engineering? This is also a very difficult, tough task. But change is inevitable. In society, always many changes will come, but we have to face them. There is no other way. For every individual, whether it is a student or a faculty member, the most important thing is the flexibility and adaptability. You must have to inculcate these two habits, then only you will survive in the field. Don't think that all software engineers are very happy in their job. They are also working at their toes only, because day by day the changes are taking place, technology changes are coming place. Unless and until they are very ready with those changes, they cannot survive. So what we have to do is, whatever our field may be, first of all, adaptability and flexibility, these two are the very important factors that every member has to inculcate. Then only you can survive the life happily and you can adjust in the profession. So I think time is running late. Chief guest is also there. I conclude with these words. And before concluding, again I am congratulating the coordinator and co-coordinator of the three departments for doing this wonderful workshop today. I wish you all the best and good luck. Have a great day. Wish you all the best.
Thank you, sir. Now I request Dr. G. Samsero sir, Director of Academics, to please share a few words about this occasion.
Professor Venkat Reddy garu, our beloved principal, Dr. N. Samsero, and my dear students, press and media, and delegates from various colleges, participants from various colleges. Once again, very good morning to all of you. First, let me congratulate Dr. N. Samsero and his team for having identified enough topic to deliberate. Secondly, identifying a person, a magnanimous person, as the chief guest of this program. I know Venkat Reddy garu is a self-made man. I had an interaction with him as controller of examination, and I wondered his dedication. He is such a dedicated man that he works from early morning to night, and in the middle of the while he is working as a controller of examination, and he used to go to the department to take the classes. Such a wonderful man he is. I should appreciate, and I request all of you to give a standing ovation to that Next, because of evolution of electrical vehicles, it becomes inevitable to identify the storage devices with high power to weight ratio and with high energy density. And you all know lithium-ion batteries are now ruling the world as an EV batteries. And India also, in its Energy 2023 policy, it has decided to improve BSS as PSS. PSS means pumped storage systems, because we have only two types of storage systems. One is battery storage system, other one is pumped storage system. It has to, now by 2027 it is trying to increase its capacity by 86 gigawatts, and by 2030 it want to increase to 246, and by 2047 it is 2380 gigawatt hours. But unfortunately now, as of today, September 2024, our BSS battery storage system capacity is only 57 megawatts. So our targets are very high. And we need to gear up with respect to the technology of storage system, especially batteries, because we are referring to electrical vehicles, and we talk about only battery storage system, lithium-ion battery storage system. So it is an odd topic. Why AI is required for the storage systems? Battery storage system, why artificial intelligence is required? Is it really required? Is to store what do you call lead acid battery, do you require AI? Nothing like that. Battery lead acid, we have only positive and negative plates and cells. Only number of cells. Okay, 6 cells for 12 volts battery. But whereas the design of lithium-ion battery system for a scooter, for a motor car, for a bus is highly complicated, and the design parameters vary drastically. Because lithium-ion batteries are very small, small capacity, and we use clusters, not like a very big, a lead acid battery. Thousands of small battery cells. Already we are using lithium-ion cells, nickel metal headed batteries, nickel cadmium batteries, and all these things. Similarly, these are also cells, small cells, and thousands of such cells you have to arrange as per your requirement. Series parallel combinations and all types of combinations. The requirements vary, especially for electrical vehicles, the requirement vary drastically. You all know the requirement. For starting the requirement, we have high power requirement, for acceleration high power requirement, for normal cruising one requirement, all this for extra load one requirement, and it changes from vehicle to vehicle because the capacities are different. There are several challenges, and also in addition to that, the charging. You cannot afford to have a charging time of 12 hours or 14 hours or 16 hours or 24 hours. Fast charging. Fast charging always generates heat. Then how to dissipate the heat? What kind of the casings could be provided? How to immediately dissipate the heat from the battery? Otherwise, nowadays you see a lot of accidents happening. That is improper design of battery. While charging, it generates a lot of heat. You understand? If that heat cannot be dissipated properly, it leads to failure of the battery, explosion of the battery. Such things are happening. So it is carefully designed that demands artificial intelligence. So that is the subject our electrical department has identified as a main topic here for next 14 days. Definitely it gives a good eye-opener for all the participants, and I once again thank the Department of Electrical and Electronics for having identified this program, and I thank our chairman for having ready the concept, given the permission to organize the program, and once again I thank Professor Venkat Reddy for having graced this occasion. Thank you very much.
Thank you, sir. Now I request Dr. K.V. Samsirao sir, Dean R&D of NRI Institute of Technology, to share a few words.
Respected dignitaries, gracing the occasion, Dr. Venkat Reddy garu, Chief Guest of today's inaugural function, Dr. C. Nagabhaskar garu, Principal of the college, Dr. N. Samsirao garu, Coordinator of this program, Dr. G. Samsirao garu, Director Academics, and Dr. Kailash garu, Assistant Director, and my dear faculty members, participants, students, and everyone. Very good morning to one now. So this topic is a very right topic at this point of time, because today there is a lot of talk about electrical vehicles. Number of inventions are going on with respect to the development of electrical vehicles. And some vehicles, they are already on the road, but number of problems are also there. Coming to the inventions or innovations that changed the human life since beginning. The first one is fire. Fire has changed the total human life and the lifestyle. That is first invention. Second invention, the wheel. Wheel has changed wheel has influenced a lot of change in the day-to-day life. Third one is electricity. So with the electricity, the second industrial revolution came up and the mass production got started. And the fourth one is computer. And computer today, without any computational activities, we cannot carry the life. And fifth invention is AI, artificial intelligence. Now, this workshop is combining invention number 3 and 5. So first of all, let me congratulate Dr. Samsirao garu for making a very good effort. Now coming to the electrical vehicles, there are vehicles which are running basically on combustion engines. So they use only the fossil fuels. So right now, the India is importing to the extent of 11 lakh crores of rupees for the oil. So this is the amount that we are spending every year to import the oil for our vehicles. So alternatively, if we have the electrical vehicles, if we develop our own indigenous technology, if we develop the vehicles which use renewable energy or energy from renewable sources or sustainable sources, probably we can save 11 lakh crores of rupees to this country, and this money can be used for the development of the country. And China, look at the China. China has given a mandate to its people and companies that by beyond 2030, 2030, there should not be any vehicle which is running on the fossil fuel. So this is a mandate. But India is at its very early stage that lot of research is going on, and still efforts are moving on towards the development of electrical vehicles. And largely we are importing R&D expertise from various other countries. So what we have to do is we have to develop a lot of R&D with respect to the development of electrical vehicles. Once again, electrical vehicles have a lot of sources of energy. One is pure battery. So battery, the vehicle doesn't have the internal combustion engine, and it is only if it is charged it can run. But the problem is when you are running a longer duration, you have to wait in between the journey and wait till your battery is completely charged. Second thing is that you can make the car hybridized. Some cars are coming even in India with hybridization. So while running your vehicle, some part of your energy is also used for generation of electricity, or used for charging the battery. Third, hydrogen cells. So hydrogen cells you can once load to the vehicle, and these cells are consumed, and the electricity is generated, and directly the vehicle can move on. And finally, one more invention which is we cannot imagine beyond. So if there is some atomic power, atomic energy, like uranium, when uranium is stored in some way, and let the car be not asking any supply from the external sources. Let the uranium run the car for its lifetime. So these days the innovations have happened with respect to the watches. So there are some watches, they are called as atomic watches, and they don't require any batteries. So they work for lifetime. So the same is going to happen with the cars. So the atomic power, it will generate enormous amount of energy which is required for running, and you don't require any other external supply for these batteries. So a lot of research is going on with respect to electrical vehicles, and I request all the participants and also the faculty of electrical engineering department, also students, to attend the program. And I have seen 14 experts, they are taking the sessions, 14 sessions. So I hope all the sessions will be useful for you and gain lot of knowledge, because this is the order of the day. And moreover, you are using AI, artificial intelligence. So artificial intelligence, you say, these days the human intelligence is getting replaced by artificial intelligence. And imagine the ChatGPT is genius. A normal person has EQ, that is 110 to 120. That is the normal EQ of a normal person. If between 120 and 130 or 140, he is extraordinary person. And if it is beyond 140, he is a genius. And there is one genius, invisible genius, who is everywhere. That is ChatGPT or AI. So ChatGPT is having IQ level 155. You pose any question, you pose any challenge, it's going to solve. As good as a genius working for you. So the AI will make multi-folds of the IQ levels with respect to machines, and machines, so this AI will automatically regulate, control, monitor everything with respect to the movement of the car. So there are self-driving vehicles. So these vehicles are working in various countries, but the problem here is some hacker hacks the data or a database of the car, and some accident happens. Then who will take the responsibility? So nobody takes the responsibility, because one is not responsible. Some mistake with respect to software, or some because of the hacking, something has happened, nobody will take the responsibility. So that's why governments are very cautious in giving permissions to all such vehicles. So we are going to have very good technology, the safe technology with respect to the electrical vehicles, and many of us will have the self-driving cars where you order your car to drop your son or daughter to the school and come back to the home. So this is going to be reality. So with the vehicle without asking for any charge, without asking for any fuel. And if it is the vehicle which is working on its own or with the direction, with the command of the owner, and if it is working, so that is going to add a new luxury to life. So this what is going to happen. So I request with this I thank Department of Electrical and Electronics Engineering and the coordinator of the program and our chairman sir, and also AICT for permitting the program, and for also giving me the chance to speak at this occasion. Thank you, sir. Thank you very much.
Thank you, sir. Now I request Dr. D. Kailasrao, sir, Academic Coordinator, to please come forward and share a few words for this session.
Respected Chief Guest Venkat Reddy garu, our beloved Principal Nagabhaskar garu, Academic Director Samsara garu, our young dynamic program coordinator Samsara garu, and CSC Dean Samsara garu, and other friends and students. Good morning. Even though I am not relating to the concerned subject, but I want to tell only 1 or 2 minutes. Energy storage. You know, in our India, the resources are very scarce in their supply. That's why the available scarce resources must be utilized in a proper way, without any wastage. And then only we can get fruitful results. Especially in our Indian economy, previously agriculture is playing a key role. But nowadays, the service sector, power sector, banking, communication, and all these things, all these sectors are playing a very, very key role. More than half of the GDP, gross domestic product, now in India we are getting from this service sector. That's why the development of our economy is mainly dependent upon the development of the service sector. Therefore, all these available scarce resources which we utilize very systematic and scientific manner without any much wastage. All the available resources, especially the energy, the power resources must be utilized in a proper way. We can save the time, we can save the energy, we can save the money, we can save the all these things. As our program coordinator Samsara Garu has taken choosing a correct topic, the apt topic for the current situation. With regard to the department of EEE, no doubt it is playing a very, very key role in our NRI institution. There's in several colleges, the department, you see, they are not filling the strength we are having, that they are having. In our department, EEE department fulfill this target. Yes, we are having 100% occupancy. It is a great, achievement. No doubt, our Samsara Garu is playing, and other department members are playing a key role in this respect. Honorability, Samsara. Okay, this 14 days program, as no doubt will gain very, very, very fruitful success, and the resource persons, I request the resource persons give a valuable suggestions for the enrichment and for the development of the economy. Thank you very much.
Thank you, sir. About our chief guest, Dr. K. Venkat Reddy, sir. So he is a professor and head of EEE Department, University College of Engineering, Kakinada, Jawaharlal Nehru Technological University, Kakinada, Andhra Pradesh. So coming to the educational qualifications, he completed his BTech in Electrical and Electronics Engineering and MTech in Power and Industrial Drives and PhD in Electrical Engineering. He has around 21 years of teaching and research experience and 15 years of administrative experience. He has worked in various capacities as the Director of Academic Planning, Director of Incubation Center, NSS Program Coordinator, Additional Controller of Examinations and Training and Placement Officer. He has many awards and prizes. He had received the prestigious awards like University Appreciation Award for Teachers and Researcher Award, Best Researcher Award, IAI and Engineers Award, Kota Prize, which is a gold medal, and Certificate of Merit in Best Papers in international conferences and journals. He has handled many R&D projects, and also he has published patents, and also he has the granted patents. He has around 79 publications, and in that 22 are SCI and others are 28, and 5 national journals and 20 international conferences and 4 national conferences. He has guided 6 PhD scholars and 8 PhD scholars are undergoing. He is a member of professional bodies like IEEE, IEI and member of IAENG, MIST, etc. So now I request Dr. K. Venkat Reddy sir to please address the gathering.
Respected dignitaries on the dais, Professor Nagabashwar garu, Principal of the college, Director R&D Samsevara garu, Director Academics Samsevara garu, and my good friend, the coordinator of the program, the head of the department of EEE Samsevara garu, coordinator academics Kailash Rao garu, of the dais, deans, heads of the departments, faculty participants, my student friends. Very good morning to all of you. And I take this opportunity first to thank the NRI Institute of Technology for inviting me to this particular program. And I have very close association with this college. I used to visit this college frequently, and during COVID, we used to conduct a number of online meetings with this college. I have very close association with the chairman of this college, Dr. R. Venkat Garu. I also take this opportunity to thank the chairman of this institution, Dr. Venkat Garu, for inviting me to this particular program and for conducting this very nice program. And I'm also excited to share the dais with these eminent personalities. And everyone is a resource person. And if you give them a day or two, they are the most suitable persons to guide you on the e-mobility, energy sector, and in all the areas of this faculty development program. Now, in the last 30-40 years, the India is focusing more on information technology. Certainly, information technology has contributed a lot to this particular country, and we have sent and we are sending huge number of youth or the techies, technical engineering graduates to the IT sector, and IT sector emerged like a big industry. Now, IT is not a big industry at this particular point of time. In the year 2015, majority of the countries have made an agreement in Paris. It's called Paris Climate Change Policy or Paris Climate Change Agreement. As per the Paris Climate Change Agreement, the world and most of the countries have signed to limit the global warming in this particular decade to 1.5 degrees to maximum of 2 degrees. And if we want to control this atmosphere, we need to take new policies. Every country is taking a new energy policies, new climate policies, and new mobility policies, and all other policies are being redefined to meet the sustainable development goals decided at Paris in the year 2015. If you see India, now the buzzwords are not in information technology, not artificial intelligence, that is energy. We have a visionary Chief Minister, Honorable Chief Minister, Sri Chandrababu Naidu Garu, used to use these words. If you look at the great personalities, and most of the latest technologies the words comes from the Honorable Chief Minister. And if you look at his speeches in the last 6 months, he is not using the word IT, and many times he is using the word energy, power, sustainable technologies, renewable energy, pumped hydro storage, and the government of AP has made many policies in this particular area in the last few months. In the last few years also, the AP and the entire country is focusing on these areas. So, this e-mobility is not related to electrical engineering alone. The electric mobility or the e-mobility is related to electrical engineering, electronic engineering more, computer science and engineering, mechanical engineering, chemical engineering. It is also related to economics or the commerce people. Conventionally, we are using fossil fuels and internal combustion engines for the transportation. And as many experts have said, there is a fast depletion of the fossil fuels. The availability of the conventional fuels like petrol, diesel are very limited. And in India, we have very few such resources. They are mostly importing them from the Gulf countries. How long we can import those energy resources from other countries? How long they are in a position to supply? The availability of these petroleum products are also very limited in nature. So we need to move away from these conventional fuels to an alternative fuel. The electricity is the most efficient and cheapest alternative fuel. And when we talk about the fuels, as engineers, efficiency is very, very important. How much natural energy we are consuming for transportation is a very important aspect. If we change from the conventional fuels to electricity as a fuel, the efficiency improves by 4 times. The energy consumption reduces to 1/4. The electricity is 4 times efficient fuel when compared to the conventional fuels such as petrol or diesel. So not only that, the emissions, the tailpipe emissions, the carbon dioxide, carbon monoxide, nitrous oxide, particulate matter, the conventional vehicle releases huge amount of pollutants into the atmosphere. If you look at the worldwide statistics, India is a great country and a green country, and we have got many rivers. The climate should be very pleasant, but what is the India's position as far as the climate or the environment is considered? Air pollutions are considered. Among 190 plus listed countries, what is our country's position? Ours is the worst 8th country to live among 190 plus countries. Not top 10, top 20, top 50. Ours is 8th from last. The worst 8th country to live as far as the climate or the environmental pollution is considered as per the latest statistics. So this is a high time to realize the importance of the pollutions, and this electricity will certainly avoid or reduces these pollutants to the maximum extent. So because of these things, the entire world is moving towards this electric mobility, and India is also in the same direction. And the last 10 years, India is also concentrating more on this. This sector gives many opportunities, not only for electrical engineers. If the IC engine is replaced with the electrical motor, so many electrical motors are required, and many electrical industries comes up. There will be a good employment for electrical engineers. To provide the controlled power supply to the motor, our electronic converters have to be designed and developed, and the manufacturing industries are coming up in power electronics sector. And in India, in 2018, Government of India has taken a policy called Electronic Policy of India. As per this Electronic Policy of India, whichever the company manufactures power electronics, normal electronics, semiconductors, and integrated circuit, whatever the electronics they manufacture, they will get a huge amount of subsidies from the government. So this e-mobility sector provides lots of opportunities to power electronics engineers and electronics engineers also. This e-mobility gives an opportunity to integrate various huge number of sensors through wide and wireless communication. So IoT technologies are coming up. The IoT finds many applications in this e-mobility sector. So there is a great opportunity for IoT engineers and electronics engineers. Then batteries are to be utilized, as many experts have suggested, effectively using battery management techniques. Cell balancing and energy optimization, energy storage, charging, recharging, and grid integration, all various aspects of this e-mobility. In all these aspects, battery management system plays a very important role. In battery management systems, electronic engineers, electrical engineers, and chemical engineers, and computer science engineers also plays an important role. The AI, artificial intelligence based algorithms, are to be placed for effective management of these batteries. Not only that, last December I was in Singapore. I visited Nanyang Technological University and its e-mobility center. They got a project of worth 350 crores aiming to develop autonomous vehicles to the Singapore. And by 2030, the Singapore has marked a particular region as an autonomous region. From 2030 onwards, only autonomous vehicles will be permitted to into that particular area. So those several hundreds of acres area, several thousands of acres area, they said it's 25% of the Singapore area is separated as earmarked as autonomous vehicles zone, and only autonomous vehicles will be permitted. This Nanyang Technological University is heading that particular research project. So artificial intelligence based algorithms, wireless communication techniques, sensors, and mechatronics, robotics plays a major role in this particular area. When we talk about a vehicle need not be a car. Vehicle can be a car, bus, truck, or your two-wheeler, three-wheeler, or a normal hoverboards for personal carriage vehicles, and agricultural drones for videography. All these drones are also the examples for electric vehicles. Of course, electric trains are also the electric vehicles. And good number of new electric vehicles are coming up. Tomorrow the world is going to change. We want more comfort. And in the near future, in the next 5-10 years, nobody carries a luggage. And if we have a trolley, and we are carrying the trolley and we are pulling the trolley now, and then after 5 years, we will not carry the trolleys also. If we walk and the trolley follows as an autonomous vehicle, it also acts as an electric vehicle. Balakrishna recently got a trailer students there. Balakrishna sir, movie actor, will throw the trolley was the So it's going to be a reality in the next 5 years, which is also an example for electric vehicles. For these days, engineering radiates creativity, critical thinking, problem solving nature plays an important role. You need to come up with creative ideas on this e-mobility. And this e-mobility is also designing a small electric robot which can be injected into veins to clear blood clots or cholesterol storage in the nerves or in the heart or in other organs of the human body. So these electric vehicles are going to play an important role in medical field and hospital area also. So micro electric vehicles. There are also runs on electric motor. So these electric vehicles ranges from nano size vehicles to big electric trucks and electric trains, electric flights, and this entire area is called sustainable technologies. This energy area, sustainable technologies, generating electricity through renewable power generation, using the energy to the with high efficiency, and protecting the atmosphere is the the important aspect of these days. The employment is going to come in this particular area. Chemistry also plays an important role, and we have our 23 batch students. I only have reintroduced this chemistry subject to all, aiming green chemistry technologies. Earlier, we have studied chemistry. Whatever the chemistry we have studied and we are practicing is not at all useful now. Now the body changed from conventional chemistry to green chemistry. Green chemistry means producing any product without any harmful byproducts. And if you are producing hydrogen out of it, and hydrogen can also be used as a fuel, as an alternative fuel for electric vehicles. If you want to produce hydrogen, we produce hydrogen through chemical reaction. So if you produce hydrogen through chemical reaction, it also releases pollutants. Now the pollution can be reduced, and producing hydrogen by reducing the pollution is called blue hydrogen. Now there is a word called green hydrogen, and our Honorable Chief Minister is also using these words these days. Green hydrogen is the production of hydrogen through electrical process. Through electrolysis, water can be split into hydrogen and oxygen, and it also releases electrons. So if you have higher amount of electrical power, and we are all electrical engineers, majority of these people are electrical engineers. We know in electricity, we don't have much storage for the electricity. Always generation must meet the load demand. This year, we have plenty of amount of rains, huge amount of water. We have huge possibility for power generation through hydel in the last 5-6 months. But if the load is less than the power generation, what can be done? And the generation must be reduced. Now we are working for other possibilities. Pumped hydro storage is one good concept that is coming up, as one of our professors also mentioning. If generation through renewable power is very high and the load is less, then excess power can be used to pump the water from low level to a very high level, that the water can be stored for future usage. After a month or after a couple of months, same water can be used for regeneration of electricity. So this electricity can be stored in the form of water in an uphill area or in a reservoir. This pumped hydro storage is also coming up. Battery energy storage systems are also coming up. And renewable energy integrations to the electrical grid is also coming up. Artificial intelligence founds many applications in this renewable energy integration and optimum utilization of the energy resources, and these electric vehicles are also going to be connected to the grid. The batteries of the electric vehicles can also be used to store the electricity of the grid. So in this control process, artificial intelligence plays a vital role. Computer science engineers will definitely work under electrical engineers after 10 years or after 5 years, and the electronic engineers and the electrical engineers plays an important role for the development of this country in the near future. So my dear friends, stay back in the electrical engineering and learn artificial intelligence, learn how to apply these artificial intelligence algorithms to the electrical engineering area and the energy sector, electrical mobility sector. This is going to give huge number of employment opportunities, not only in India but also in the Western world. And in the last 5 years, I've introduced this electric vehicles course at JNTUK KAKINADA. I'm handling this particular course, and though during COVID we got very few admissions to our MTech, and 4 of our MTech students are working in e-mobility sector right now, placed in the e-mobility. They're drawing more than 15 lakhs per annum salary. When I mentioned this 5 years back, they have not believed. Sir, कृपया वाला कि MTech के placements ले लो, माग jobs are అది 15 లక్షలు 12 లక్షల, and whoever followed my guidance are drawing 15-16 lakhs at this particular point of time. They'll definitely draw 30-40 lakhs in the next 5 years to come. And many PhD holders, the candidates who have completed PhD in power electronics area, electric mobility area, who have hands-on experience of writing MATLAB programs, Simulink programs, dumping these Simulink programs to D-space controllers or FPGA controllers through Xilinx or through any platform, and controlling power electronic equipment through digital controllers, and also getting industrial opportunities. I think Principal Garu was mentioning that electrical engineers are not going to get good opportunities. So this time, the doctorates who have hands-on experience on operating power electronic converters and drives are getting 10 lakhs to 15 lakhs packages in industries. Some of my known persons are working for Mahindra, and some of them are working for ZF Technologies, which is a German-based company which has software development in India. Programs will be developed in India, tested in India. This will be uploaded to their central server, and these equipment will be manufactured in Germany. And these equipments are exported to different parts of the world from Germany. And they are just like software engineers, but not in IT sector, but in energy or electrical engineering sector, sustainable technology sector. So this sector is going to give us huge number of opportunities, and in the next 5 years, EEE, the electrical and electronics engineering, is going to play a vital role in the entire country and in the institutions also. Our admissions are going to increase, and our placement opportunities are going to increase, and I request all of you to stay back in electrical engineering domain. Please, at this particular point of time, please do not look at IT. Computer science engineering students will look at the IT, but electrical engineering students, you will be more successful in this particular sector than in the IT sector. And with this, I once again take this opportunity to thank the organizers and the coordinator of this 2-week faculty development program, my good friend Professor Samsura Garu, and the Principal Nagavaskar sir, the directors, the faculty members, and the chairman of this institution for inviting me to this particular faculty development program. And I thank each one of you for your patience listening. And sorry if I take more time. And thank you very much. Thank you.
Thank you, sir. Thank you for your valuable information. As we conclude this auspicious inauguration of our faculty development program, it is my privilege to extend a vote of thanks to all those who have made this event possible. First and foremost, I would like to express my deepest gratitude to our chairman, Dr. Ravi Venkatreddy sir. Your vision and unwavering support are the cornerstone of our success. A heartfelt thank to our HOD, Coordinator of ATAL FDP and Controller of Examinations of NRI Institute of Technology, Dr. N. Samsira sir, for your continuous guidance and leadership. Your commitment to excellence inspires us all. To our principal, Dr. C. Nagavaskar sir, your words today have been a source of great motivation and encouragement. Thank you for your steadfast support. Our profound thanks to our Chief Guest Dr. K. Venkat Reddy sir for gracing us with your presence and sharing your invaluable insights. Your contribution has set a high tone for this program. Our Academic Director, Administrative Director, Dean R&D and Academic Coordinator, thank you for your meticulous planning and seamless execution of this event. Your efforts are truly commendable. I would also like to extend my gratitude to all the speakers of these enlightening addresses and the participants for their enthusiastic engagement. Your involvement is what makes this program meaningful and impactful. Lastly, a special thanks to the faculty of EEE department for their hard work and dedication behind the scenes. Your efforts have ensured the success of this inauguration ceremony. Thank you all once again for your presence and participation. With this auspicious beginning, let us look forward a fruitful and inspiring faculty development program. Have a wonderful day.
I wanted to cover the basic aspects of electric vehicles. Then charging schemes for electric vehicles, battery charging and charging schemes. before I start my session, may I know how many of you have studied these electric vehicles? May I know how many of you have already studied electric vehicles or hybrid electric vehicles while doing your B.Tech, M.Tech? Or how many of you have handled these electric vehicles course in your college? Only one. So rest of the candidates, electric vehicles is a new area. So most of you are new to this electric vehicles course. I was also new, though I was a electronics man. I did my B.Tech, M.Tech, PhD from JNTUK campuses. B.Tech from JNTUK, M.Tech also from JNTUK campus. But I was doing my M.Tech, I started working on switcher reluctance motors. Yes, I am switcher reluctance motor back in 2002. And I completed my M.Tech on control switcher reluctance motors. PhD also in switcher reluctance motor. And I was into special electrical machines mainly for electric vehicle applications. Then I entered into renewable energy technologies, the power quality aspects, application of power electronics to power systems. Then into e-mobility sector, power converters, charging stations, etc. In the last 7-8 years, I'm mainly working on renewable energy technologies and e-mobility. I've been handling this course in the last 5 years, not only to EEE students, but also to ECE students. This year and last year, I have handled this particular course to B.Tech final year ECE students. 50 out of 50 of the ECE students have opted this course this year. Last year, majority of the ECE students and other students have also opted this course. And this year, complete ECE class, along with few petroleum students have also opted this course. So what do you understand by electric vehicles? In this today in the morning session, in the next 12:20 to 12:25, first 1 hour I will explain what are electric vehicles, what are the different, how can we classify these electric vehicles, what are hybrid electric vehicles, and what are the different architectures of hybrid electric vehicles, different components of electric vehicles, and little bit on batteries, fuel cells, ultra capacitors. So by that we get a basic introduction about the electric vehicles, its functioning. And in the afternoon session, let us focus on charging of electric vehicle batteries. What are the different types of charging schemes we have? Slow charging, fast charging, ultra fast charging, and then smart charging. Then what are the different types of chargers we have? And what are the different types of connectors we have for charging? Then what is smart charging? Then vehicle to grid integration, and the role of artificial intelligence or wireless communication in the e-mobility sector. In the afternoon session, 2 hours. What are electric vehicles? Simple. If the electric motor is used for driving the vehicle, such vehicles are called electric vehicles. Conventionally, we are using internal combustion engines to drive the vehicle. If we replace the internal combustion engine with the electric motor, such vehicles are said to be electric vehicles. So when we started developing these electric vehicles, any guess? 20 years back? 10 years back? 40 years back? We started developing these electric vehicles long back. We have made an attempt to construct electric vehicles way back in 1830s. Soon after the development of electrical motors and the batteries, we have started using these electric motors for transportation purpose. 1830s. By 1880s, we were successful in implementing electric vehicles along with conventional internal combustion engine vehicles. By 1900, both are equally popular. Internal combustion vehicles and electric vehicles both were equally popular during 1900s. Then in early 1900s, one electrical engineer has improved the performance of IC engine. Normally, IC engines are not self-starting devices. Some of you might have conducted experiments on the IC engines, prime movers and pumps, and whatever the course you study and whatever lab you have conducted. You might have operated IC engines. How do you restart IC engines? By rotating a big wheel. We need to rotate the wheel to start the IC engine. Or it can be old bikes, 20 years back bikes, which do not have self-starting mechanism. How do we start those bikes? Through kick rod. Now, how auto rickshaws are getting started now? Conventional auto rickshaws. By lifting a rod. By lifting a rod, what are they doing? By lifting the rod or by using a kick rod, we rotate the internal combustion engine. If you rotate the internal combustion engine and it also takes the fuel, it continues to run. As it is not a self-starting machine, we need to start this machine by applying a mechanical effort, which is very inconvenient. In the early 1900s, our great electrical engineers have helped these mechanical engineers by placing an electrical motor. IC engine is started. Electrical motor assisted IC engines. So this self-starting, the push button start or self-start or ignition start IC engines. So then from then onwards, IC engines have become very popular, and we were lagging for many decades. Now it is our time. The electric vehicles are getting very popular. So why do we need electric vehicles? We have mechanical conventional vehicles. We are happy with them. What is the need for electric vehicles? In general, whenever you say about the electric vehicles, we quickly recollect environmental protection, global warming, because it's also a reason, but not the prime reason. There are many other factors for global warming, not only electric vehicles. Still we are operating thermal power generations, still we are operating VDPS. How much pollution it releases? Still we are burning wood, still we are burning diesel, still we are burning agricultural crops, still we are burning many other things which are releasing harmful gases and polluting the atmosphere in India. That is the reason why India is 8th position from the last as far as this environment is considered. But protecting the environment is very important. But India is not so, we are not so cautious. And if you go to European countries, go to Netherlands, Switzerland, there we can easily live for 120, 130 years happily if you are in Netherlands or Switzerland. It's 100% pollution free and it's good atmosphere. So the prime reason is, as engineers, our basic responsibility is to develop efficient systems. For the output, the input should be as minimum as possible. The efficiency should be as maximum as possible. When we talk about mobility, vehicles are meant for mobility, moving. For 1 kilometer transportation, how much natural energy we consume? It's an important aspect. So the prime duty of the mobility engineer is to reduce the energy consumption and to develop the vehicle which consumes very less amount of energy for the transportation. The energy point of view, or energy consumption point of view, or efficiency point of view, these electric vehicles are 4 times efficient when compared to mechanical vehicles. So for each kilometer travel, how much energy is consumed by the mechanical engines or conventional engines? We are using vehicles, 2-wheelers or 4-wheelers. If we consider a simple 5-seater car, How much mileage we get for a 5-seater petrol car? Hardly 15 kilometers to 20. In city traffic and the combined mileage will be around 4 to 15. How much is the cost of the fuel? 110 rupees. For each kilometer travel, how much we are spending? 7 rupees plus for each kilometer transportation. Not only in terms of the money, in terms of the energy consumption also. So 7 rupees we are spending for each kilometer transportation of a 5-seater car. If you replace the internal combustion engine with an electric motor, how much energy is required for the transportation of electric vehicle to 1 kilometer? So in India, we have a few popular electric vehicles. One popular electric vehicle is Tata Nexon EV. Tata Nexon says it consumes only 130 watt hours. 130 watt hours for each kilometer travel. 1000 watt hours. 1 kilowatt hour is called 1 unit of electricity. How much is the 1 unit electricity cost for essential purpose? Around 4 rupees. And we are not happy with 4 rupees. We want to reduce this 4 rupees to 2 rupees. See, it's possible once you generate the power through renewable power, slowly power prices will also be reduced. 4 rupees is comfortable. So by spending 4 rupees, how much a distance you can travel? For each kilometer, 130 watt hours. The Tata is saying, practically let it be 150 watt hours. Or we are running in local road, we don't know how to operate electric vehicle. Let it be 200 watt hours. With the 200 watt hours on higher side, practical side, how much distance we can travel for 1 unit of electricity? 5 kilometers. For 15 kilometers, 3 units. For 15 kilometers, 1 liter petrol costs 110 rupees. For 15 kilometers, 3 units of electricity cost 12 rupees. So one side 12 rupees, and the other side 110 rupees. This e-mobility is that effective, that efficient. So electrical energy is the most efficient form of energy for transportation. So it is not a new or latest investigation. We know this for the past many decades. Even during human beings, to make the human life more comfortable, more happier. So if you want to provide this mobility provision to all the candidates, as I was mentioning, to develop different vehicles for the transportation of goods, transportation of luggage bags, and during my childhood, during my colleges, we used to comment, when washing Kalana vehicles can tomorrow, అక్కడ కిచెన్లో నుంచి హాల్లోకి రావాలంటే ఓవర్ బోర్డు మీద నిల్చొని కిచెన్లో అలా గంట తిప్పేసి అలా హాల్లోకి వచ్చి టీవీ చూసుకుని అలా వెళ్తారేమో. మై వైఫ్ యూస్ టు కామెంట్ ఈ వెస్ట్ ఫేసింగ్ ఫ్లాట్ స్పేషియస్ ఫ్లాట్స్ నాది కాదు మా JNTUది. ఐ యూస్ టు సేమ్ JNTU ఫ్లాట్స్ 2000 SFT ఆగ్నేయం నుంచి అందుకొని టీచింగ్ రావాలంటే వీళ్ళు ఒక సీరియల్ పెట్టుకొని కుకింగ్ చేసుకుంటుంటే తిరుగుతుంటే సో దేస్ టు ట్రావెల్ సెవెరల్ కిలోమీటర్స్ ఇదే ఇన్ ద హౌస్. ఏమో ఇన్ ద నెక్స్ట్ 3-4 years ఎవ్రీ హౌస్ మే హ్యావ్ ఏ హోవర్ బోర్డ్, దాని మీద నిల్చుని ఉంటారు, అదే కిచెన్లో తీసుకెళ్తుంది, ఇక్కడ తీసుకెళ్తుంది. అండ్ ఎవ్రీబడి వాంట్స్ టు యూస్ మోర్ సచ్ గ్యాడ్జెట్స్. నా ఫ్లోర్ క్లీనింగ్ ఆల్సో ఇన్ ఇండియా, ఇన్ విజయవాడ, ఇన్ AP, many houses are having robot cleaners. There are also electric vehicles operated on electric motor and the batteries. So many such vehicles are coming, and once the fuel costs are reduced, once battery technologies are improved, everybody uses many such vehicles. The other aspect is environmental issues. India is in worst situation, and as quickly as possible we need to stop avoiding we need to stop reducing the fuels, carbon dioxide, carbon monoxide, nitrous oxide, and sulfur oxides, and particulate matters, PM 2.5, PM 5, PM 10. The particulate matter whose size is less than 2.5 micrometers, they are very dangerous for the human body. These pollutants may cause skin allergies to skin cancer, breathing lung allergies to lung cancer, eyesight to blindness. The effect of these pollution cannot be estimated. And the persons who are working in chemical industries or who are residing just beside the chemical industries are facing these problems. These are the main reasons for moving away from the conventional vehicles and preferring electric vehicles. The advantages of electric vehicles can be listed as sustainability, efficiency, convenience, and economy. Sustainability. If you use conventional vehicles, the internal combustion engine based vehicles, how long we can use the conventional vehicles? How long we can spend 8 rupees per kilometer towards a fuel? And as population is increasing, number of vehicles are increasing, and if vehicles increases, how long the Gulf countries supply this fuel? In the next 5 years, if the petrol price increases to 200, how many of us are able to use the vehicles? And no, if we are using a 4-wheeler, we will come back to a 2-wheeler, or we use this 4-wheeler only for emergency purposes or other purposes. These days also, though we are all having 4-wheelers, we don't use these 4-wheelers to come to the colleges. Many of us, though we have 4-wheelers, we use buses, college transportation to public transportation or college transportation to reach the college. Why? These fuel costs. So now also we are compromising. If you continue the same, how long we can survive, how long we can sustain. If we consume the complete energy, tomorrow for the next generation we may not have they may not have any petrol or diesel sources. Sustainability is a very important aspect. Sustainability is in terms of the availability of the fuel and pollution. If the conventional vehicle releases pollution, we may not survive for hundreds of years. And if you compare when to build efficiency of the conventional vehicle and with the electric vehicle, it's not about pricing. We may say that in India we have 110 rupees. If it is in Dubai, the price may be less, or if it is in US, price may be less. How can we compare this? If you compare energy consumption, first one is, if you use internal combustion engines, if we extract the crude oil, in the Gulf countries we extract the crude oil and we transport the crude oil to different countries, to Kakinada, to Machilipatnam, or to different port areas mainly. Near those port areas we have refinery units. We refine this crude oil, we extract petrol and diesel, then we transport this petrol to the different cities, and through petrol pumps we distribute it to the customers. This crude oil extraction process is 80 to 85% efficient. This is the European scenario. In Indian case, it's less than 60% efficient. Mostly from Gulf countries to Europe, it's very short distance. It's very easy to transport. If you want to transport the crude oil all the way from the Gulf countries to Kerala or to our Machilipatnam, Kakinada ports, it's a long distance. The transportation cost is also very high. And these days, crude oil extraction costs are also increasing. Those crude oils are not available on the top surfaces. We need to go very deeper to extract the crude oil. The crude oil extraction is also getting costly. The overall efficiency is, if you extract 1 liter, around 30%, 40% of this is to be spent for extraction purpose itself. Then if it is 70% efficient, then if you supply petrol or diesel to IC engine, how much is the efficiency of the IC engine? Normal range of efficiency of IC engine. Maximum 40%, highest point, and minimum 20%. Normally they operate at 25 to 30% efficiency. These IC engines will not give highest efficiency at all speeds. If you plot a characteristic with the efficiency versus speed of the IC engine, speed of rotation, it's like a sinusoidal shape, a bell curve. The efficiency increases, and if speed increases, efficiency falls. If speed reduces, again efficiency falls. At a particular speed, the IC engine gives highest efficiency. The highest efficiency is not 90%, 80%, 70%. Maximum 35%, 36%. See, by improving these IC engines with the Euro 6 or Euro, whatever the norm you mentioned, highest possible efficiency is 40% maximum. On an average, it gives 20 to 35% efficiency. Overall efficiency is 16 to 29%. See, for each kilometer travel, if it takes 150 watt hours per kilometer for a normal 5-seater car, it is 16 to 29%. How much energy is to be spent, natural energy? Around 500 to 900 watt hours. 500, 900, 25-30% of it is 150. At the end, at the wheels of the vehicle, it requires 150 watt hours per kilometer. To provide 150 watt hours at wheels, how much natural energy they are consuming? 500 to 950, depending upon the vehicle. Let it be 700 or 800. If we use same through electrical vehicles, for electric vehicle also for mobility, wheels requires 150 watt hours per kilometer. Then what are the different processes involved here? Power generation, power transmission, and then power utilization, charging process and power utilization. Power generation may happen through idle, through renewable, or through thermal. If it is thermal power generation, what is the worst way of generating electricity? Thermal power. Lowest efficient way, least efficient way of generating electricity is thermal way. Let us consider thermal way to compare with the IC engines. In thermal power generation, by burning gas or coal, the efficiency of this will be around 85%. Electric power transportation is highly efficient. Though we study power systems 1, power systems 2, power systems 3 for improving the efficiency of the transmission, and we transmit the electricity at the highest efficiency. To transmit electricity at highest efficiency, what do we do? EHVAC transmission, HVDC transmission, high voltage, extra high voltage transmission. Through this, transmission losses are minimized. Transmission is highly efficient when compared to any other energy transmission. If you want to transmit one tanker of petrol from Srinagar to Vijayawada, how much energy it consumes? Probably half of the tanker. And if you want to transmit same amount of electrical energy from Srinagar to here, very small losses. That is the reason why we are able to transmit electricity. We are able to import electricity from Gujarat and the different parts, where I am able to export electricity to different parts. Then if you use electricity for transportation, transportation 90%. If you use the same electricity for electric vehicles, the charging and discharging process involves some amount of losses. Still, even you consider 85% efficient batteries. If you store 100 units, if it gives 85 units, including battery losses, power converter losses, etc., 80% is the lower side for electronics. Whereas power electronic converters operates at 95%, 98% efficiency. These days, batteries are also giving more than 90-95% efficiency. And lower side, even you consider 85% efficiency, overall efficiency will be 26 to 43%. 35% is for sure. Even if you consider thermal power generation. So if you consider 150 watt hours with the same efficiencies, how much natural energy we are consuming, how much energy we are consuming from nature, 340 watt hours per kilometer if you use gas. Coal, slightly higher. And renewable, not listed here. Renewable, if you use renewable energy, so we consume very, very small. If that is 150 watt hours requirement, energy, natural energy will be 250 maximum. Against this 500 to 750. Not only efficiency, CO2 emissions. If you use conventional vehicles, for each kilometer, CO2 emissions 140 to 270 grams per each kilometer. If you use electricity, it is very, very less. Even you use coal burning, the CO2 emission, overall CO2 emission is 135 grams per kilometer against 145 to 270 grams per each kilometer of conventional. If you replace the conventional vehicles with electric vehicles, the CO2 emissions can be controlled, natural energy consumption can also be reduced. As a whole, the electric mobility is 4 times efficient when compared to IC engines. Other aspect, most of us we expect convenience. We have a beautiful e-classroom. We have normal classrooms also. In normal classroom, we can have a projector without air conditioner. And by this air conditioner hall, cushion chairs, nice display, nice ambience, convenient. Everybody wants to be very convenient. And we expect more convenient. And the technology aim is to provide these convenience and comforts to the people. So if you want to have more convenience, electric vehicles offers more convenience. How? The size of the drivetrain will be very small when compared to IC engines. If you replace IC engine with electric motor, the size of the engine reduces. The number of moving parts reduces. The gearing arrangement is not required. And many other components are not required. As a result, the vehicle will be very light. And the engine space will be very small so that your boot space can be increased. This boot space can be used for other gadgets, for other comfortable things, or you can be very spacious also. Please.
Doubts there?
Yes, please.
Gears are meant for different riding conditions.
Sir?
Gears
Okay.
are
Yes, sir.
there for different riding conditions.
Yes, sir.
Say if I am going uphill, let us say, why can't we have a gear in electrical vehicle?
In electrical vehicle, electric gates are also available, sir.
Yeah.
Electrical gates, but not the conventional gates. I'll explain in one of the slides. I've made a comparison also in conventional mechanical gearing arrangement and electrical vehicle speed torque characteristics. I think you are from mechanical engineering.
Yes.
I'll answer the question. So while in this session itself, I'll explain why do we use conventional gears, first gear, second gear, third gear. You have high starting and low starting. How can we control our electrical emissions? I'll answer this question. And many IoT technologies are coming up. Many electronic gadgets are coming up. And earlier, air conditioner was luxury in vehicles. Now, we have a movie theater inside, we have good sound system. Whenever we enter into the car, automatically depending upon our taste, ambient lighting must be changed. And I may be interested in blue color, and my wife may be interested in pink color. My kids may be interested in different colors. The ambient lighting must be changed. And normally for my car also, conventional car, whenever I reach my car, automatically when I touch the door handle, the vehicle unlocks automatically. And tomorrow, what we expect, if I get down from this particular building, the vehicle come to the portico, it should wait for me. And depending on my activities, it must turn on the air conditioner before I get into it. The temperature must be cooled down to 20 degrees centigrade, 22 degrees centigrade before we start. And this is what we expect. And probably we will reach all these things in the next 5-6 years. So all these conveniences are possible, comforts are possible with electric vehicles when compared to IC engine based vehicles. Price, we have compared the fuel cost with the conventional vehicle and the electric vehicle. The electric vehicles offers more, the transportation is very cheap when compared to the IC engine based transportation. Economic point of view, we can save huge amount of money. If you look at the brief history of these electric vehicles, we have started developing these vehicles during 1830s. By 1880s, we have developed electric vehicles. From 1880s onwards, by 1900, we had good cars. By 1930s, we got beautiful cars. Those days, Rakineni and NTR used to drive good vehicles, and when compared to these two, Rakineni used to drive posh vehicles with the left side steering imported from US, UK, big vehicles. So, those days, these electric vehicles were also equally beautiful. Even 1960s, it appears like a premier company those days, parallel to Akineni. Savitriga used to have such vehicles in the 1930s. And even these electric vehicles were also popular, also good those days. The 1990s, 2007 and 2005 to 2007, 2004, 5, 6, those days, many electric vehicles were launched in Indian market, in AP also. Many of us, our parents, our other family members, relatives, have purchased good number of electric two-wheelers and a few electric cars also. Why they have purchased? They have promoted these electric vehicles in a big way. They said that if you purchase an electric vehicle, every month you can save this much amount on the fuel cost. In the next 3 to 4 years, you can save lakhs of rupees on this. Then everybody has purchased electric, many of us have purchased electric cars, and many villages also have purchased electric scooters. Then those scooters, they were not happy and those were not successful. What is the reason for that? The companies have said that if you purchase an electric scooter with 60,000, 70,000 rupees those days, and next 3 years, 3 to 4 years, you can save 30,000 rupees towards your fuel cost. It's true. And those days, for every 3 years, the entire battery pack needs to be replaced. The lifespan of the battery was only 3 to 4 years at a time. And if you save 30,000 rupees towards fuel cost, and they are supposed to spend 40,000 rupees towards the replacement of the battery. And now, secondary reason is how much distance we can travel. If you fully charge the scooter or if you fully charge the car, how much distance one can travel? It's an issue. They used to give 30-40 kilometers for bikes and 80-90 kilometers for the cars. If I want to go to Hyderabad on the car, and we need to we need to stop at 2 different locations minimum, and we need to wait for 8 to 10 hours for charging the car. It was very inconvenient. That is the reason why many it's not like these electric cars. Even use scooters. If you fully charge a scooter, that can give you a range of 70-80 kilometers maximum. Practically 50-60 kilometers. So many retired people have purchased, or many women have purchased for local travel purpose. And every day they will use it for 10-15 kilometers. And then after using this for 15 kilometers, immediately they have connected the vehicle to the power socket for charging. If you frequently charge the battery, lifespan of the battery reduces quickly. The lifespan of the battery depends upon number of charge-discharge cycles. If you frequently charge, the number of charge-discharge cycles completes very quickly, the lifespan of the battery reduces. Same is the case with our mobile battery also. These days we change our mobiles for every 3 years normally. What is the lifespan of our mobile batteries? We need to ask students, ask our students. How much time, what is the lifespan of your mobile battery normal? How quickly you are changing the batteries? 2 years? 3 years? Two years. Okay. What is the reason for that? We can easily use these mobile batteries for 4 years to 5 years. Why we are replacing the batteries, or why the battery life is reduced to 2 years is, if once you fully charge the battery, we need to connect the charger only when the state of charge comes down to 20%, 30%. If you use this mobile phone 4 hours or 5 hours or complete day, the battery gets discharged to 30%. If you connect the charger to charge the battery from 30% to 100%, I can use it. This process is, one cycle is completed in this process. 100% charging to 30% discharge, and from 30% charge to 100% charge. One cycle is completed. Most of the batteries gives 4,000 charge cycles. At least 2,000-2,500 charge discharge cycles. If you charge your mobile once in a day, how many days life it gives? 4 years minimum. So normally what we do, we connect a charger and we use the mobile. The battery gets discharged and it is charged. The number of charge discharge cycles increases. And if your battery is not having, and your mobile phone is not having proper battery management system, the lifespan of the battery reduces very quickly. Same is the case with electric vehicles. So many villagers are uneducated or purchased electric vehicles, and after using these electric vehicles for 5-6 kilometers, connect the vehicle to a socket, switch it on overnight, it continues to charge. Those days, the battery management systems were not developed. If you charge the battery for a longer period, the battery gets heated and the battery lifespan reduces. And for every, some of them have changed their batteries in the first year itself, and many complaints have raised, and the suppliers have stopped supplying these electric vehicles and they've stopped using the electric vehicles. Now many electric scooters have released, many electric cars have released in the last 3 years. Recently Ola has released a good number of electric scooters. What is the situation of Ola? Being electric vehicle expert, I have also invested 5 lakhs on the Ola stock and launched at 76 rupees, increased it to 150 rupees and came back to 70-71 rupees now. Electric vehicles కూర్చోవాలంటే Ola పెట్టుంటారు చాలా మంది. Having confidence on this and trusting the professional ethics పెట్టుకొని, and this confidence we have on this sector. Now what is the reason for that? Why? Soon after the launch of these electric vehicles by Ola, the stock price has increased up to 150 rupees. Now within a span of 1 month, Ola stock price reduced to 50%. Several thousand crores was lost to the customers and the investors. What is the reason for that?
Demand versus supply.
And they're able to supply, but there are two reasons. One reason is many customers are not able to use these electric vehicles properly. They are not able to charge, and even for small things also they are not able to repair, and repair options are not available. Because of these reasons, maloperations have happened.
Service.
And for silly reasons also, the vehicle is to be brought to the service station, and there was big queues in front of the service stations. The service experts are also not available, and as a result, they took almost 20-25 days to clear the service request and to solve the problems. Many software issues. Whenever we load a particular software, and when there is a big competition, everyone wants to release the product very quickly. The testing process has not conducted thoroughly, and as a result, there is to be small bugs, small issues in practical level. And when there is a small issue, the vehicle will not be started, and vehicle may not shift the modes from one mode to other mode, or may not operate. The electronic chips may not operate properly. Because of the many electronic component issues, Ola has faced many problems. And they could resolve all the issues. By the time there is a big negative publicity on these Ola scooters, and it definitely takes another 3 to 4 months time to come back to its normal condition. So the point to be noted here is the customers are also not having proper awareness on how to charge the vehicle, how to use the vehicle, and the service options are also not available. Because of these reasons, still the customers are not preferring electric vehicles. If you go to US market, they are not proactive, or they are reluctant for the change. Indians, we always like to change. If any new technology comes, we love to use the technologies. The best example is the UPI. We were in 2015-16. We worried when another Prime Minister said about UPI payments, online transactions. We worried. Now within a span of 2 years, even beggars have accepted UPI payments. So we are so quick in adapting technology, and if we go to US market, they are not proactive towards the technology. In US, still, even though the Elon Musk is the owner of Tesla and SpaceX, is with the president of the US, Donald Trump is not in favor of the electric vehicles. The president of the United States, president-elect of the United States, is opposing the electric vehicles. They are very happy with the conventional vehicles, though they are less efficient. So in India, what is the present situation of electric vehicles in India? There are about 5% of the vehicles are electric vehicles at present. India has got a target of having at least 30% of the vehicles as electric vehicles by 2030. As per the climate change policy agreed in France, India has a target of replacing at least 30% of the vehicles with the electric vehicles by 2030. In many European countries, Netherlands and many European countries have a target of having 100% of their vehicles as electric vehicles by 2030. But in India, as it is a very big country, definitely takes much time. By 2050, we will have all the vehicles as electric vehicles. So 2030 target is 30% of the vehicles. Other reason for not preferring electric vehicles is lack of charging stations. By 2019, we had very few charging stations in India, hardly 150 charging stations. Several thousands of charging stations were sanctioned during COVID period. Now by 2024, India has around 10,400 charging stations. 10,000 odd charging stations and 10,470 charging stations at this particular point of time. By 2030, we have got a target. Can you guess how many charging stations we want to establish in the next 60 years? 14 lakhs. India wants to establish 14 lakhs charging stations in India to meet the requirement of the customers. So how many power electronic components are required? How many electronics wired and wireless components are required? How many IoT devices are required? How much AI technology is required? In charging process, our expectation is both wired charging, wireless charging, smart charging, and I'll take my vehicle to the charging station and I'll operate my mobile phone, or I'll operate my car dashboard. I'll keep my settings. I want my vehicle to be charged at this particular price, or whatever may be the price, I want to charge my vehicle in the next 15 minutes. I'm on the way to a city and I want to rush as quickly as possible. I can spend here only 15 minutes. How much amount do you want? I'll pay, charge my vehicle within 15 minutes. So like that, customer may set different conditions through mobile apps, through apps installed in the vehicle itself. So different types of charging schemes are coming up, like our mobile phones. I purchased my first mobile phone in 2001. We need to spend 300 rupees towards the recharge card. They used to give you a talk time of 180 rupees after taxes and all. Out of this 180 rupees, the outgoing call cost is 6 rupees per minute. There is a charge for incoming call also, 3 rupees per minute. If you spend 300 rupees, 180 minutes talk time, 180 rupees talk time, and 30 minutes outgoing call, or 60 minutes incoming call, cost 300 rupees. Later by the next year itself, by 2002, we got night offers. After 9 p.m. to morning 6 o'clock, and half of the price. Later, night incoming free. After a few years, daytime incoming free, only outgoing cost. And later we got many packages. And Reliance has entered by 2004 or so. Reliance has entered. Then if you pay 500 rupees, they have given CDMA technology mobile phone, and no SIM card. SIM card is also not required. Whatever the usage, for the usage, we need to pay the bill. They have got a package. If you pay 500 rupees per month, outgoing free, incoming free, now we are enjoying by paying few hundreds of rupees every month. Similar to this, electric vehicle charging schemes are also coming up. Many packages or many schemes are coming up. So we can choose different packages. So one can guess how much digital infrastructure is required, how many number of apps are required, how much AI-based business will get in electric vehicle charging station, in charging process. Once you have 14 lakh charging stations, not by 2050-60, by 2030. Who are studying electrical engineering now, last bench, who are studying electrical engineering now, are going to use all these technologies during your work after your graduation. This is the scope for electric vehicles. In Indian market, we have got many electric vehicles. If you look at the sales, surprisingly, Uttar Pradesh is doing really good when compared to our southern states. They have a good number of three-wheelers also. Many three-wheelers. Uttar Pradesh is doing good. Maharashtra, Karnataka, Tamil Nadu. Where are we? We are at 3% by 2023. And for AP, we have got a different characteristic. Andhra కొంచెం ఆరంభంలో కొంచెం వెనకాల చేస్తారని కానీ once we step in, history repeats. Probably in the next 5 years, we may be at the top position. Worldwide scenarios, as I said, Norway has 74% of their electric vehicles by the year 2020. by 24, by this time, they got a target of replacing 100% of their electric vehicles by 2030. But mostly, they might have replaced it by this time. And then followed by Ireland, Sweden, and most of the European countries. Surprisingly, where do you have US? Not at the top. US is also at the bottom with a 2.5%. And their mindset is they are not so quick to adapt the changes. They are very happy with conventional. They are able to provide subsidies for the fuel cost. They are not worrying about the efficiencies. Many, every country is entering into US and yearning for the US, and they are happy with their finances. Now, situation of US is also not good. Economic part of it. Slowly they will also realize. And China with 6.2%. So, which country is having the highest number of electric vehicles? Last bench, which country has highest number of electric vehicles? Norway has highest percentage of electric vehicles. 75% of their vehicles are electric vehicles. But in terms of number of vehicles, how much is the population of Norway? How many number of vehicles they have, total vehicles?
China.
Out of the total vehicles, 75%.
China.
If they have 1 lakh vehicles, 75% is 75,000 vehicles. How many vehicles India is having? How many vehicles China is having? 6% of the China vehicles is much higher than the Norway's vehicles. So the China has highest number of electric vehicles at this particular point of time. Next, India will also have more number of electric vehicles. So the point to be noted here is, where do we have more number of EV users, EV customers? In China and India, where we have highest population, out of 800 crores, China has 140, India has 140, India and China put together 300 crores out of 800 crores. So India and China is almost 50% of the business of the entire world. If Tesla is manufacturing good electric vehicles, where do they sell? In Norway, few vehicles. In US people also use, though their population is less, they use good number of vehicles. Everybody has a vehicle. They are not interested to change their vehicles to electric vehicles. What is the best place for EV market or for Tesla? Elon Musk. India and China. It's very difficult to enter into China, but it's very easy for US people to enter into India. That is the reason why Elon Musk is trying to enter into India. It's not required to invite Elon Musk to India by Modi ji or by Chandrababu Naidu. They will come for their business. India has got very good potential for electric vehicles. So once we have huge number of electric vehicles, unless we manufacture the power electronic components, unless we manufacture electric motors, then power converters, the controllers and the softwares within India, we need to import all those technologies from China or from US. If you develop our technologies through Tata Motors or Tata vehicles, Mahindra vehicles or any other Indian vehicles, so revenue comes to India. Otherwise, most of the revenues will be transferred to US or China. So we've got big potential for EV market in the next 20 years. We are aware Tesla is one good vehicle. An Indian market, we have got beautiful vehicles, electric vehicles. Whenever we talk about electric vehicles, we are showing only cars. We have got buses and trucks and scooters, three-wheelers, so many electric vehicles. Out of the cars also, electric cars are not 20 lakh, 10 lakh normal cars. Electric car costs up to 1 crore, 1.5 crores also. We have got good vehicles from BMW, we have got good vehicles from Volvo, we have got good vehicles from Mercedes-Benz, from premium companies, we have got electric vehicles. And the most popular electric vehicles in India are Kota Nexon EV, which costs about 20 lakh rupees on road. Base vehicle costs about 17-18 lakh rupees to 24 lakh rupees. Tata Nexon EV is doing really good. And from Hyundai, Kona Electric.
Back, sir, back.
Kona cost is not listed here.
Yes, sir.
Hyundai Kona Electric is also a good vehicle in Indian market. It's about 20-25 lakh rupees. Now, when compared, if you compare this electric vehicle cost with conventional vehicles, 20 years back, the cost of the electric vehicles were very high when compared to conventional vehicles. Even these days also, in the last 2-3 years, the electric vehicle cost is 25% more than the conventional vehicles. Why these electric vehicles are high costly when compared to conventional vehicles? And these, do the electric vehicles have more components than conventional vehicles? No. And the electric vehicle has less moving parts when compared to IC engines, less size engine, and less other parts when compared to conventional vehicle. Still, and the new technology costs very high. They used to invest huge amount of money towards the R&D, so that the initial days, the cost of the technology will be very high. Slowly, the technology cost will be reduced. There is one reason. The main reason is the cost of the batteries. If the vehicle costs 17 lakh rupees, if the Tata Nexon EV cost about 17 lakh rupees, the electric vehicle battery, the battery of the Tata Nexon EV costs 7 lakh rupees. These days also, Tata Nexon has a 30 kilowatt hour battery to 45 kilowatt hour battery. If you choose 40 kilowatt hour battery, the cost of the 40 kilowatt hour battery at present is 7 lakh rupees. 20 years back, if you want to have similar type of battery, it used to be 14-15 lakh rupees. In last 7-8 years, the cost of the batteries are reduced to less than 50%. Still, the battery technologies are improving, battery costs are reducing. So at this particular point of time, a 40 kilowatt hour battery for Tata Nexon EV or such type of vehicles costs about 7 lakh rupees. Total vehicle cost is 70 lakh rupees. In the next 3-4 years, the battery cost is reduced to 4 lakh rupees. Vehicle cost definitely reduces to 14-15 lakh rupees. By the time technology will also be, if number of vehicles or the sales increases, automatically cost of the vehicle also reduces. We hope this Tata Nexon vehicle cost will be reduced to 14-15 lakh rupees by 28-29. And the size of the battery will also be increased. So main limitations of these electric vehicles are the average on-road price of these vehicles are slightly higher than the conventional vehicles. Then these days, still we require more number of charging stations. Inadequate charging infrastructure. We hope by 2030 we will overcome this with 40 lakh charging stations. Then dependence on battery imports. The cost of the batteries are increasing because we don't have materials within India. We are importing battery products, battery components from China, Japan, and other countries. Unfortunately, for the last 40 years, we have focused more on information technology. We have never considered chemical engineering as engineering. We never considered chemistry as a useful subject in engineering. Now, as a result, we are importing the batteries. And we don't have lithium-ion battery cells research and development within India. Now, we are realizing the importance of other technologies. Range anxiety. Earlier, the vehicles used to give 70 kilometers, 80 kilometers if they are fully charged. Now, the present day electric cars are giving you a minimum of 400 kilometers once the vehicle is charged. If the vehicle is fully charged, it gives you a range of 400 kilometers. So, range anxiety is slightly reducing, but still, I want to go to Hyderabad, and after shopping in Hyderabad, I need to come back to Vijayawada by today evening. And if I want to wait in outer ring road area in Hyderabad for 4 hours for charging, 5 hours for charging, it may not be convenient for us. We want to have quick charging. So what is our target? Earlier, electric cars used to take overnight for charging, 10 hours. Now the charging time is reduced to 4 hours. We got fast chargings also. After lunch break, let us discuss those things in detail. How much time we expect? What is our expectation?
10 to 15 minutes.
So our benchmark is conventional vehicles. How much time our conventional vehicle takes to fully charge? How much time your conventional vehicle takes to fill your tank? 5 minutes.
5 minutes.
Maximum 10 minutes including waiting time. So we want to completely charge our vehicles in 5 to 10 minutes. That is our expectation. How much distance it has to give if the vehicle is fully charged? Our expectation. Same as conventional vehicle. If the conventional vehicle has 40 liters tank, by burning each liter, if it gives 15 kilometers per hour, so if you full tank your conventional vehicle, it gives you a range of 600 kilometers. From electric vehicles also we expect the same. If fully charge the vehicle, it should give a travel distance of 600 kilometers range. And to charge the vehicle, 5 to 10 minutes. Those are the expectations. By 2024, we have reached 400 to 450 kilometers travel range. Some vehicles are giving 500 plus also. But practically, they say 500, it gives 400. Even Tata Nexon EV is also saying, with a 30 kilowatt hour battery, they are saying 400 kilometers travel. It's not possible practically. If they are brought into highway, Nalasala road without any traffic and flat surface, it gives. But in practice, not give. But we have reached 400 kilometers range. We are able to charge the vehicles in 4 hours time. By 2030, we will certainly reach 600 kilometers range, charging the vehicles in 10 minutes. How much time our mobile phones are taking to charge these days?
Hardly.
Fast charges?
Hardly 10 minutes, 10 to
20
minutes, 20 minutes.
Earlier, during 2001-2, and they used to, in instruction sheet, they used to write, for the first time, connect the charger for 8 to 12 hours. From next time onwards, it used to take 3 to 4 hours to charge the batteries. Now, within a span of 15-20 years, we have reached to 10 minutes. And afternoon, let us discuss this fast charging also. Is it good or bad? So time is very important, but the lifespan of the battery is also very important. Efficiency is also important. Price also important. So still charging infrastructure needs improvement and quality maintenance options. If you have a conventional vehicle, scooter or bike or a car, and if you have a Maruti vehicle, in every street and in Vijayawada, in every street we find a mechanic. Battery repairs, every street we can find a good mechanic. If it is an electric bike, if it is an electric scooter ఆగిపోతే మన ఫ్యామిలీ మనవాడు మీరు ఎలక్ట్రికల్ ఇంజనీర్ కదా మీరు చేయలేదా స్టార్ట్ చేయలేదా మీరు బీటెక్ చేశారు కదా ఎంటెక్ చేశారు పిహెచ్డీ చేశారు బైక్ స్టార్ట్ అవ్వదా అండ్ we don't have the awareness and we don't have repair options. Once we are trying, and the best example is the mobile phones. When I purchased my first mobile phone, after a year small repair, I went all the way from Anantapur to Abits, Hyderabad Abits, to get my mobile phone repaired in Narayan Mark, Abits. అక్కడ ఇచ్చి నైట్ వేరే హైదరాబాద్ JNTUK గెస్ట్ హౌస్కి వెళ్ళి పడుకోవాలి. నెక్స్ట్ డే వెళ్ళి మొబైల్ కలెక్ట్ చేసుకుని వచ్చాను. In the year 2001 or 2. Now by 2005, every town have got 10-15 repair shops. Now, mobile అమ్మేవాడే నీకు రిపేర్స్ ఏమంటారు అక్కడ చూపెట్టి సాల్వ్ ఆ చిన్నది పోతుంది మనకి ఏం పోయిందో కూడా తెలియదు. దాంట్లో ఎలక్ట్రానిక్ కాంపోనెంట్స్ 10 రూపీస్, 12 రూపీస్, 18 రూపీస్ లేక కిలో కిన్ని ఇలా అమ్ముతారు. దాంట్లో చిన్న కింద చార్జర్ పిన్నిపోయి ఉంటారు. మన ఛార్జ్ పని చేయట్లేదంటే సాయంత్రం ఇస్తామంటే 6,000 అవుతుంది, 4,000 అవుతుంది, 3,000 అవుతుంది అంటే మొబైల్ డిస్ప్లే పని చేయదు. లోపల జస్ట్ కనెక్షన్ పోయి ఉంటుంది. చిన్న స్ట్రిప్ ఏదో మార్చుంటాడు, 5 రూపీస్ 6 రూపీస్ పడుతుంది. మనకు తెలియదు అది ఏం మార్చాలి. ఎలక్ట్రానిక్స్ ప్రొసెస్ కూడా ఉంటాం. మన ఎలక్ట్రానిక్స్ ప్రొసెస్ అక్కడికి వెళ్తే వాడు చెప్తాడు 10th క్లాస్ 6,000 అవుతుంది సార్ డిస్ప్లే పోయింది పోయిందా మార్చేసి ఈవినింగ్ కూడా 6 రూపీస్ స్ట్రిప్ వేసి ఈవినింగ్కి కంప్యూటర్ అంటించేసి మన చేతిలో పెట్టి అంత 4/6,000 రూపీస్. ల్యాక్ ఆఫ్ క్వాలిటీ రిపేర్ ఆప్షన్స్ cost to the customers increases and customers may not feel convenient. Once we get the awareness, ఆ తర్వాత చేసుకుని అక్కడ నుంచి ఓపెన్ చేయడమ్మా ఏం పోతుంది నా దగ్గర వేసుకుంటాం. నెక్స్ట్ స్లోలీ మన ల్యాబ్లో కూడా పెట్టుకోవచ్చు. ఐ థింక్ దిస్ ఇస్ ద రైట్ టైమ్ టు హ్యావ్ మొబైల్ రిపేర్ ఆప్షన్స్ టు ట్రైన్ our students, our electronic students on these mobile repair options, at least to understand what are the different components we have inside. Similarly, the electric vehicles. Most of the institutions are setting up electric vehicles laboratories, battery technologies laboratories, so that awareness can be created, people can be trained, and so that everybody adapts this technology very quickly. So, this is the basic introduction of the electric vehicles. In the afternoon session, I'll briefly explain what are different classifications of electric vehicles we have, what are hybrid electric vehicles, what are series hybrid electric vehicles, what are parallel hybrid electric vehicles, and series parallel and complex configurations for hybrid electric vehicles, need for hybrid electric vehicles briefly, and then let's move on to charging infrastructure. These basic things you can find anywhere. But these days, most important thing is charging infrastructure. How do we charge the electric vehicles? What is level 1 charging, level 2 charging, level 3 fast charging? Then what are the different modes of communication can be established between a vehicle and a charging station? Mode 1, mode 2, mode 3 and mode 4. Then we have what type of chargers we have, charging connectors. Type A connector, type 1 connector, type 2 connector, and Tesla connector. And then for CCS, what is combined charging scheme, both AC and DC charging schemes. What are the different connectors we have? What is GB/T or Chademo charging connector? And we have Bharat 001 protocol also. And what are the different charging technologies we have? Future technologies like wireless charging technologies, dynamic charging, static charging and dynamic charging. Then what is smart charging? These computer science engineers also play an important role here. How big data analytics helps, how machine learning algorithms helps in e-mobility. What is the role of big data science? Data science graduates in e-mobility. The role of AML graduates in e-mobility sector. And the role of electrical engineers in the e-mobility sector, renewable energy integration, smart grids, and vehicle to grid interface. That will cover in the afternoon session. Please do us in the afternoon. I try to finish it in 1.5 hours. Sorry about 3 o'clock. With your permission, we continue up to 3:30. 4 o'clock. And wherever you get any doubt, it's only an interactive session. And you please stop me and ask. And if you feel bored, also you raise your hand and stop. And I have expected 4 hours time for these sessions. If the time reduces, we quickly go through it, we may skip some of the important points. After completion of this, I'll leave these slides PDFs with you. Prepared good problems also in electric mobility. I'll give these problems also to you, so that if you teach these e-mobility to your students, you can solve these problems also. For any course material or any type of thing, the teaching faculty may contact me regarding the electrical vehicles. And I request you to kindly offer this course in the colleges to create awareness to electrical engineering students and electronic engineering students also. Thank you, and that's made in the afternoon session.
Itself in the same block. Thank you.
Next 1 hour 15 minutes, in the first 15 minutes I will try to explain what are hybrid electric vehicles, need for hybrid electric vehicles, different configurations of hybrid electric vehicles. In the next 1 hour on charging schemes and charges. Electric vehicles can be classified into pure electric vehicles and hybrid electric vehicles. What are pure electric vehicles? If the entire drivetrain is by the electrical motor alone, and if the electrical motor takes the power from battery or the fuel cell, such type of vehicles are called pure electric cars or battery electric cars. All electric cars, pure electric cars, these are different names. To drive the vehicle, we use a drivetrain. If the entire drivetrain is by the electrical motor, such vehicles are called pure electric vehicle. On the other hand, if electrical motor assists the IC engine, if both electrical motor and IC engine both drives the vehicle, such type of vehicles are said to be hybrid electric vehicle. If the total capacity of the car is 100 HP, for example, if 50 HP electrical motor, 50 HP IC engine, both IC engine power plus electrical motor power is total power 100 HP. Such vehicles are called hybrid electric vehicles. What is the need for hybrid electric vehicles? Initially we have tried for pure electric vehicles. We were not successful, we were not happy with pure electrical vehicles because of the different reasons. One reason, high battery cost, low range, and the performance of those vehicles were also not good. In terms of the starting torque, in terms of the pickup of the vehicle. And 20 years back, those old electric vehicles, so the pickup was not satisfactory when compared to IC engines. So, to help these IC engines, electrical motors are also placed. If electrical motor is placed, total energy consumption, total fuel consumption reduces. And as one of the director in the morning was mentioning, braking energy can be recovered. Most frequently we apply brakes. Around 20% of the energy gets wasted during braking process. Whenever you apply brakes to conventional vehicle, the kinetic energy will be converted into heat energy. The energy gets wasted, gets dissipated in the form of heat. This energy can be recovered using regenerative braking. If electrical motor is connected to the IC engine, when you apply brakes, when the vehicle is decelerating, this motor acts as a generator and generates electricity. The generated electricity can be stored inside the batteries, and that battery stored energy can be used by these motors for driving. See, if the vehicle is having 50 HP IC engine, 50 HP electrical motor, 50 HP IC engine takes the fuel from the fuel tank. Remaining 50 HP electrical motor takes the power from battery. How batteries get charged? These batteries get charged only during regenerative braking. Whenever vehicle, what is the size of IC engine? Only 50 HP. This 50 HP engine is consuming the fuel. 50 HP engine consumes less fuel and mileage increases. practical case, for example, we are familiar with Toyota Innova vehicle. If you consider Toyota Innova petrol, how much mileage it gives? Hardly 10, 11, 10 kilometers per liter. And we have got a Toyota Innova hybrid vehicle, wherein electrical motor is also placed along with the IC engine. Whenever you apply brakes, this motor acts as a generator and stores energy. The stored energy is used by this motor to drive the vehicle. So along with the IC engine, motor also drives the vehicle. As a result, fuel consumption reduces. Mileage increases from 10-11 kilometers to 17-18 kilometers. At least 15-16 kilometers per liter is sure. So what is the advantage of hybrid electric vehicles now? Regenerative braking is possible, and energy can be saved. Heat energy can be stopped. Temperature rise can be controlled. Fuel efficiency can be increased, and fuel cost can be reduced. So in the last 20 years, we are working on this the hybrid electric vehicles also. As these hybrid electric vehicles are also using IC engines along with motors, though motors are not highly performing or at a high performance, combination gives the best performance. The pickup of the vehicles are also very good. Such type of vehicles are said to be hybrid electric vehicles. Electric vehicles can be classified into different types: pure electric vehicles and hybrid electric vehicles. Under hybrid electric vehicles, depending upon the size of electrical motor we place, these hybrid electric vehicles can also be called as micro hybrid, mild hybrid, hybrid, and extended range diesel, small diesel engine can also be placed there. In your conventional vehicle, we use electrical motor also for your normal petrol bikes, petrol scooters, petrol or diesel cars. We also use electrical motor. What for? For starting parts. As I was mentioning in the morning, whenever you push a button or whenever you start your engine, this motor takes the power, motor starts the engine. After starting the engine, motor also acts as a generator, we call it as a dynamo, charges the battery. This motor will not drive the vehicle, it just assists the engine for starting purpose. So such type of vehicles are said to be micro hybrid, because motor also involved along with this IC engine. Not for drivetrain, just for starting purpose. If a small motor is coupled with the IC engine, 90% of IC engine, 10% electrical motor. Out of 100 HP drivetrain, 90% bigger IC engine, 10 HP motor, small motor. So total combination 100. In such case, this combination is called mild hybrid. So this motor generates electricity, can also act as a generator, and regenerative braking can be applied. And if out of 100 HP, 40 HP electrical motor, 60 HP IC engine, or 50 HP motor, 50 HP IC engine, or 60 HP motor, 40 HP IC engine. So when these type of electric vehicles are called hybrid electric vehicles. To classify these hybrid electric vehicles, we also use a term called hybridization ratio, or the degree of hybridization. The degree of hybridization is defined as the ratio of electrical motor capacity to the total capacity of the drivetrain. If 30 HP electrical motor and 70 HP IC engine are connected, how much is the degree of hybridization? Last middle is the last which questions are if a hybrid electric vehicle is having 70 HP IC engine, 30 HP electrical motor, what is the degree of hybridization? The degree of hybridization is defined as the ratio of electrical motor rating to the total rating of the vehicle, total drivetrain capacity. So what is electrical motor capacity here?
30.
30 HP.
30.
Total drivetrain capacity?
100.
30 plus 70, 100. How much is the hybridization ratio? 30%.
30%.
Clear? What is the degree of hybridization for your conventional petrol scooter?
Zero.
You phone different options, what is degree of hybridization for your? Do you have a scooter? Scooty unna? You ready? For a conventional car, for any conventional IC engine based vehicle, what is degree of hybridization? E4 level. How much is the degree of hybridization for a conventional vehicle? What is the expression for degree of hybridization? Rating of electrical motor by rating of electrical motor plus rating of IC engine.
0%.
In your conventional vehicle, what type of engine or motor which is driving the vehicle? Only IC engine. Electrical motor is not driving the vehicle.
Zero.
So electrical motor capacity is 0. 0 by
100.
total plus 0. How much is that? 0.
0.
How much is the degree of hybridization for a pure electric vehicle?
100.
100%. So depending upon the degree of hybridization, these electric vehicles are classified as pure electric vehicles to pure conventional vehicles. In between, micro hybrid, mild hybrid, hybrid like that. So if the degree of hybridization is 40% to 60%, those vehicles are called hybrid electric vehicles. What are the main parts of an electric vehicle? All parts of a conventional vehicle, and only engine is replaced with electrical motor. If engine is replaced with electrical motor, fuel tank is not required. What is required? Which supplies the power to motor?
Bad.
Electrical power is required. Electrical energy is stored in batteries. Battery stores DC power. DC power must be converted to AC for AC motors. Actually, I am also an expert in special electrical missions. I thought of taking the session on special missions for electric vehicles. But that can be conducted on third day or fourth day, not on the first day. We normally use AC missions, induction motors, synchronous motors, particularly permanent magnet synchronous motors, permanent magnet brushless DC motors, switched reluctance motors, synchronous reluctance motors are the latest type of motors which are used in electric vehicles. So present day electric vehicle uses permanent magnet synchronous motor or permanent magnet brushless DC motor, or latest vehicles are using synchronous reluctance motors. If anybody is interested to work on the drives area or drivetrain design, electrical missions or special electrical missions for electric vehicles, the best area is synchronous reluctance motors. So these motors are AC motors. Battery DC energy must be converted to AC power. So which power electronic device is used to convert DC power to AC power? Last achivare chevara. Which power electronic device is used to convert DC battery power to AC power? Inverter. A power electronic inverter is used. We have current source inverters and voltage source inverters. We prefer voltage source inverters normally. So this electrical motor, and before the electric motor we need a voltage source inverter. The voltage source inverter is controlled by a converter. The controller may be a DSP based controller, FPGA based controller. What is a small size vehicle is microcontroller is also sufficient to control. it generates gating pulses and it controls the inverter. Before that, it takes the power from battery, and there must be a DC to DC converter to take the power as per the requirement of the motor. So this is the basic structure of an electric vehicle. Conventional vehicle part, at the bottom of it, the yellow part is the battery. In electric vehicles, we don't use a single battery cell. We use number of battery cells. We use lithium-ion battery cells, nickel metal hydride, or lithium air batteries. We have wide variety of batteries. Among them, lithium-ion batteries are being used. We are aiming at solid-state batteries. At the end of this, I'll also introduce solid-state batteries. So, fire accident-free, explosion-free batteries. Why? Thousands of battery cells are connected in series and parallel to have required amount of voltage and current ratings for the battery. And the cell voltages must be balanced. Each cell must produce equal amount of voltage and total voltage must be equal on all parallel paths, and currents in the series path must be same. Total battery cell management is very important. It's where we develop different technologies called battery management systems. BMS is a mechanism developed and stored inside a microcontroller or any electronic chip. It senses different parameters like cell voltage, temperatures, and currents, etc. It always monitors the voltages of the cells. It maintains all the cells at uniform voltages, and overall battery will be protected. It monitors charging process, discharging process, takes the decisions when to connect the charger, when to disconnect the charger. Even though it is plugged and switched on, this power electronic converter disconnects the switches, disconnects the power supply, connects the power supply, etc. It also controls at what voltage level, at what current level the battery is to be charged. So the battery management systems is a good area for electronics engineers, electrical engineers, and computer science engineers also. The state of charge of the battery, whether 80% charge is there, 70% charge is there, cannot be measured by any equipment. Can only be estimated using different algorithms. This is where artificial intelligence based algorithms can be applied for the effect or the accurate estimation of the state of charge and state of health of the batteries. Then we can find a motor and a power electronic converter. There must be a charger to convert AC power to DC power, and DC power is supplied to a battery through an onboard charger. These are the main components of any electric vehicle. If you have a hybrid electric vehicle, in addition to the electrical motor, we found internal combustion engine also. For vehicle transmission system, internal combustion engine is connected, motor is also connected. If you have a motor, you must have inverter. Inverter takes the power from a battery or ultra cell or a fuel cell or an ultra capacitor. And this must be controlled by a microcontroller or a DSP controller or an FPGA controller. We need to write the program here using, you have wide variety of the schemes. If it is an induction motor, we have scalar control schemes, not sufficient for electric vehicle. We have vector control techniques, field oriented control techniques, direct arc control techniques, and for PMSM, BNDC, we have wide variety of closed loop control techniques to control the torque and speed of the motors. So those techniques are stored inside this controller. This controller generates a gating pulses to this converter. This converter basically converts DC voltage to AC voltage. If you use a two-level converter, a simple two-level voltage source inverter, the AC voltage will have harmonic content. The total harmonic distortion of a two-level converter will be 35% and above. If such power supply is received by the motor, motor performance reduces and motor windings get heated. There will be a bearing failure and the motor will be failed. So the THD must be reduced by using filters. If you use a two-level inverter, cost of the filters increases. Size of the filters also increases. So we normally use multi-level inverter here. That may be diode clamped inverter, flying capacitor inverter, cascade edge switch inverter. We have wide varieties of multi-level inverters we have. If you have 5-level inverter, 7-level inverter, the output voltage waveform will be very much near to sinusoidal wave, so that the total harmonic distortion content will be very less, and the filter requirement will be very simple, so that the motor takes harmonic free power supply, it works well, it gives a longer life and better performance of the vehicle also. These hybrid electric vehicles can be classified into different types: series hybrid electric vehicle, parallel hybrid electric vehicle, series parallel, and non-series parallel or complex hybrid electric vehicle also. When do you call a system as a series system? In electrical sense or in engineering sense, if the output of the first one is connected as input of the second, input to the second one, such systems are called series systems. If you clear the preliminary examinations, then only you will be permitted for mains examinations. So these prelims and mains are connected in series. If the candidate wants success, he must clear both prelims and mains. If the candidate wants engineering admission, either through MSET or through ESET or JEE, and these are the parallel options, either through national level entrance examination or through state level entrance examinations, one can get the admission into engineering. So if he is successful either at the state level or in the national examinations, he will be successful. In such case, this system is said to be in parallel. So parallel system requires success of any one of these cases to have a system success. If the candidate clears both, he also gets a seat. Here, what are the different components we have in hybrid vehicles? Motor and IC engine. If the electrical motor and IC engines are connected in series, such configuration is called series hybrid electric vehicle. In this case, the IC engine takes the fuel, gas, petrol or diesel or gas, whatever the conventional fuel we have. It generates electricity. So it generates mechanical energy. It converts fuel energy into mechanical energy. This mechanical energy is applied to a motor. This motor drives the transmission system. What type of energy motor requires? Electrical energy. So this mechanical energy must be converted to electrical energy. IC engine takes the conventional fuel, generates mechanical output. This mechanical output is connected to electrical power. This electrical power is applied to the motor. Motor drives the vehicle. Then this type of configuration is called series hybrid electric vehicle. If you want to have 100 HP capacity of vehicle, what should be the capacity of this motor? Here, both IC engine and electrical motor are not driving the vehicle. Only electrical motor is driving the vehicle. What this IC engine is doing? IC engine is just generating electricity that is required by the motor from conventional fuel. What is the total fuel for this vehicle? For this series hybrid electric vehicle, what is the fuel that is consumed? Conventional fuel. Externally, we fill the fuel tank. This IC engine takes the fuel, generates electricity. This electricity is used to run the motor. Motor drives the vehicle. So inside the engine, it has both IC engine and electrical motor. But fuel to this vehicle is conventional fuel, either petrol or diesel. This type of configuration is called see this hybrid electric vehicle. Is this configuration useful? Is this configuration efficient? Many hybrid electric vehicles uses this configuration. Why this configuration is not useful? It requires additional motor, additional generator, and if this is AC motor, this AC mode cannot be connected to this. There must be a controlled power. AC power must be converted to DC to store in the batteries, and DC to AC. If the excess power is available, that will be stored in the battery. And if the power is not sufficient, battery also discharges. During regenerative braking, it acts as generator and stores energy in the battery. It's all okay. But it requires more number of components, more stages of conversion. As a result, you feel that the efficiency may be less, and size of the drivetrain is also big because of additional motor, etc. But still, many hybrid electric vehicles use this configuration. Advantage of this configuration is, if this IC engine is directly connected to the transmission system, that is a conventional vehicle. In conventional vehicle, it takes the fuel and engine rotates. Engine is directly connected to the transmission system. What is the drawback of that? If the vehicle speed varies, IC engine speed also varies. If IC engine speed varies, what happens to efficiency? Varies. Efficiency will be maximum at 30% or 35% at a particular operating condition. If speed increases, efficiency downs. If speed reduces, again efficiency downs. On an average, engine efficiency is maintained at 20% hardly. But in this case, this IC engine is free from the vehicle. This is not connected to the vehicle. It can be operated independently at high efficiency point. So it can always be maintained to operate at 40% efficiency or 35% efficiency. This 35% generator converts this energy into electrical energy. What is the efficiency of the generator? Most of the electrical machines these days are giving you more than 80-85% efficiency. 85%. Power electronic converter, 98%. Again, inverter, 98%. This motor, 85%. You calculate roughly 40 into 0.85 into 0.85 into 0.98 into 0.98, which will be much higher than your conventional vehicle. If this IC engine is directly connected to the transmission, it gives an average efficiency of 20-22%. If the vehicle is at rest, if the conventional vehicle is at rest, still engine continues to rotate and consume power. If you have this type of configuration, if the wheels are not rotating, the motor will not rotate, motor will not consume any power. And this provides regenerative braking option also. When the vehicle is slowing down, this motor acts as a generator, recovers energy. So overall, this configuration gives more energy, more efficiency when compared to a conventional vehicle. Still, tailpipe emissions, but this IC engine operates at highest efficiency. It consumes conventional fuel only. It looks like a normal car filled with petrol or diesel, but it gives better efficiency. The cost of this configuration will be slightly higher because of the presence of these power electronic converters and motors. The other configuration is parallel configuration. In parallel configuration, IC engine and electrical motor are connected to the transmission system. If it is 50 HP plus 50 HP, only IC engine can drive the vehicle, or electrical motor can drive the vehicle, or if want to recharge, this mode can be changed to IC engine mode, and the vehicle can be operated in IC engine mode or the combined mode also. When compared to series configuration, it appears like a better configuration. theoretically, but practically, Padma garu. Tesla vehicles lo first lo use chesina induction motor ni కనిపెట్టింది ఎవరు? Tesla. These induction motors are also called Tesla motors. The inventor of induction motor is Nikola Tesla. So Elon Musk has started this Tesla company, has started using induction motors. Now he is not using induction motors for his Model S. He has replaced the induction motors with PMS or PMDLAC motors. He is working on synchronous reluctance motors. So what are the main components of electric vehicle now? The transmission system, an electrical motor drives the transmission system. This takes the power from a DC bus. DC power is converted to AC power and AC power is applied to the motor. DC bus, from where it gets power? From battery. From battery stores DC power at low voltages. This low voltage is stepped into high voltage using a boost converter, DC to DC boost converter. This high voltage is inverted to AC power. AC power is applied to the motor. Normally this voltage it will be 72 volts, 96 volts, 100 plus, somewhere around 100 volts in the battery. This voltage is converted into 300, 400 volts depending upon the motor capacity at higher bus. How these vehicles gets charged? It takes the power from the grid. From grid we get AC power. AC power is converted to DC power using rectifier. Then DC power is fed to the battery through DC to DC converter. In charging this to this, DC to DC. While the motor is taking the power from battery to this DC. So this converter must be a bidirectional DC to DC converter. Then we have an inverter here. Here also power flows from DC to AC to the motor. When the motor is acting as a generator during degenerative braking condition, this power flows from AC to DC and then DC to through DC to DC converter to battery. Regenerative energy will be stored in the battery. Again, vehicle uses different other equipment, other small motors, and your conventional vehicle also uses wipers to clean the front windshield, wiper motors, wiper pumps, window glass up and down, seat movement, air conditioner, power steering motor, and many other electrical motors and electronic gadgets are used, which requires DC voltage at the medium voltage level and low voltage level. This high voltage DC will be converted into a low voltage DC, 12 volts, 18 volts, a maximum of 48 volts. The DC voltage converted into a low voltage DC using DC to DC converter. This is normally called a buck converter. It is unidirectional converter. These devices will not inject any voltage. Later in your research you may have integration of renewable energy sources here. You can place a small PV panel, or you can have power generations, small size power generations. Those powers can be used to meet the requirements of the auxiliary devices. If you have surplus power, this power can also be fed to the DC mains through this converter, making this converter as a bidirectional converter. Now, as of now, this converter is a unidirectional converter. Power flow is from grid to DC, then to battery. Then now we are talking about vehicle to grid technologies. We are going to connect these vehicles to the grid when the vehicles are being charged, when the vehicles are being parked, when vehicles are at rest. So during parking, if the vehicle wants to charge, it takes the power from the grid, battery can be charged. During peak load conditions, when grid requires power, there is a big demand, the grid may discharge these batteries This battery energy can be fed back to the grid to meet the required demand. In electrical engineering, the biggest problem is to match the power supply and demand. Demand continuously varies. Power generation must also be varied to meet the load demand. Sometimes, if the load increases suddenly, the power is not available. That's why we are working for storage systems. These electric vehicles can also be used as storage systems when the vehicle is connected to the grid. During off-load conditions or during off-peak conditions, the power is available at less price. After a few years, in India also power prices are going to be varied. Now power prices are fixed at 4 rupees, 5 rupees depending upon the usage. In the near future, once the smart meters are installed, and during night time they may say the power is 10 paise per unit. On a particular day with peak conditions, now the power is 4 rupees, 5 rupees, 6 rupees per unit. So if you have these storage systems, your vehicle can be charged when the power is cheap, and you can allow your vehicle to decharge when the power price is high. So by connecting your vehicle to the grid, by storing the energy at a lower price and by selling the energy at higher price, we can also earn money. This is called vehicle to grid technologies. Once vehicle to grid technologies are implemented, this converter must be operated in bidirectional mode. So research can be done on this. So research is going on these areas. For vehicles, we need batteries. As it is the first day, I am introducing all the concepts. Actually, I thought of covering these things in the morning and exclusively charging in the afternoon. Tomorrow onwards, Professor Ravindra is coming and he will cover more on power converters, mainly inverters. And then one more slide is available with me. I will also cover special electrical machines and charging techniques in depth. As many of you are, except one, remaining all are new to this electrical vehicles, I am concentrating more on the fundamentals. I will also touch upon the batteries that are required. We use lead acid batteries, nickel cadmium batteries, nickel metal hydride batteries, and lithium ion batteries. Lead acid batteries can store a small, in the given space, the energy storage will be very small. Energy density of the lead acid batteries is very small. And in vehicles, what is our expectation for batteries? When we talk about electric vehicles or any vehicle, the vehicle weight must be very small. If the weight is more, F is equal to m into A. If m increases, if you want to accelerate the vehicle, force requirement increases. And if you have some amount of force, if you want to have acceleration, mass must be less. So weight of the vehicle must be as minimum as possible to quickly accelerate the vehicle to have highest mileage. So if you want to reduce the weight of the vehicle, battery size or battery weight must be reduced. Small battery must store more amount of energy. What is our target in terms of storage? It must meet the, it must give a range of 600 kilometers. So we must have a longer range, but the weight of the batteries must be small. So energy density of the batteries must be high. Because of that particular reason, we prefer lithium ion batteries when compared to all other batteries. We are working on lithium ion batteries to improve the performance of the lithium ion batteries. Next advanced version of lithium ion batteries are called solid state batteries. Solid state batteries are also lithium ion batteries, where the electrolyte is not a liquid electrolyte or a gel type soft electrolyte. It will be a hard metal or a graphite type of electrolyte, so that it will not have any explosion. Another worry when we purchase electric vehicles, we watch videos on YouTube, TV9, and we see many explosions of electric vehicles, fire accidents in electric vehicle showrooms, and the batteries are prone to such incidents. Still, though we are electrical engineers, we do worry about the batteries and the electricity. Once these batteries, electrolytes are changed, once the batteries are changed to solid state batteries, this possibility of explosion or fire accidents can also be avoided. So the size of the battery will also be very less, and it stores more power inside the batteries. Tesla, Toyota is also working on such type of batteries. This slide gives you overall specific energy storage and power capacity. What is the difference between power and energy? Power is how forcefully, how effectively you can do it as a work. Energy means not once, you must continue the same for a longer period. Electric vehicle point of view, power means if the battery discharges more amount of power, using more amount of power, the vehicle can start very quickly. The power is required to start the vehicle very quickly. More energy is required to move the vehicle for a longer distances. If you want to have 600 kilometers range or 500 kilometers range, the energy storage must be as maximum as possible. If you want to move the vehicle at high acceleration, initially if you want to have high starting torque or high amount of force, power is required. The battery must have higher amount of power, higher amount of energy density also. Lead acid battery gives low energy density and low power. This is the general characteristic. Nickel metal hydride is somewhat better in terms of energy capacity, specific power capacity and energy capacity. Lithium ion batteries are the best among different batteries. Have highest power capacities and highest energy capacity. If you want to operate at this particular point of time, power will be very small, energy is less. If you operate at this particular point, power will be more, energy will be less. If you operate at this particular point, this much power, this much energy. And we are using lithium ion batteries and operating at this particular point. What is our goal? Very near to it. Somewhere here. We want to have some more performance from lithium ion batteries. So we are very near to our goal, and in a couple of years down the line we will reach this. If you use petrol engine or diesel engine, the fuel tank capacity is 40 liters. We are able to travel up to 600 kilometers. This is engine. If this battery capacity reaches this particular thing, electric vehicles will be much efficient, much effective when compared to conventional engines. That is our ultimate target. We have ultra capacitors. Ultra capacitors cannot store huge amount of power, can store small amount of power, but can discharge this power at a faster rates. Because this ultra capacitor stores energy in the form of a static field like capacitors. So, though it stores a very small amount of energy, the power capacity is very, very high. These ultra capacitors are used in combination with batteries. These ultra capacitor discharges energy only at the time of starting the vehicle. So, at the time of starting, energy is quickly supplied to the motor, starting torque will be very high. Fuel cell, I think you have heard about fuel cells. What is a fuel cell? Fuel cell appears like a battery, but it will not store any energy. It generates electricity. It takes hydrogen as a fuel. It converts hydrogen fuel into electricity. It takes hydrogen, it takes oxygen from the air, it performs a chemical reaction between hydrogen and oxygen. H2 plus O2 is equals to H2O. It releases water and it also releases electrons. The flow of electrons is called electricity. If you supply hydrogen to this fuel cell, it generates electricity. It also releases water. Instead of storing the electricity in the batteries, convert this electricity into hydrogen, store the hydrogen in the cylinders inside the vehicle. Cylinder releases hydrogen, using fuel cell convert hydrogen into electricity and use the electricity. Such type of vehicles are called fuel cell vehicles or hydrogen vehicles. You would have seen several hydrogen buses. I think hydrogen buses are also running in Vijayawada. In Tirumala, Delhi, in many other places we got hydrogen buses. So how hydrogen bus work? We store hydrogen in the cylinders. Slowly the cylinder releases hydrogen to the fuel cell. Fuel cell converts hydrogen into electricity. This electricity is used by the motors. But the fuel cells are very costly these days. Still there is big research is going on. In the next 5-6 years we may expect great reduction for the fuel cells. If you have excess power, this power can be converted into hydrogen through electrolysis process. This hydrogen can be transmitted like petrol or diesel. Hydrogen can be filled inside the tanks. Tomorrow for our houses also we may also use hydrogen. Greenco is one good company. The owner of the Greenco is also hailed from KAKINADA region. He is also working along with the government of AP in the last 4-5 years for pumped hydro storage in Kurnool district. A very big solar plant in Kurnool district. The power saved and power generated through solar panels will be transmitted to KAKINADA. They are taking over the spectrum power and NFCL also. They are combining the efforts of people equipment in NFCL, a chemical fertilizer company, and the spectrum power. They are generating hydrogen. Green hydrogen or blue hydrogen? Last word.
Green.
If they generate hydrogen through electrolysis, how do you call this process? As green hydrogen production or blue hydrogen production?
Green.
Green hydrogen. Why we use the word green hydrogen? It will not release any harmful gases. It is not through chemical process. It is through an electrical process. These are the new technologies that we are coming up. On that capacity I just covered. That's the first part. We have got another part. 15 minutes time. Normally, we use batteries for electric vehicles. We need to charge the battery. Battery stores energy. Energy is equals to power into time. Power is equals to voltage into current. If a vehicle has 40 kilowatt battery, for example, Tata Nexon EV or Toyota or equivalent vehicles are using 40 kilowatt hour battery. If the vehicle is using 40 kilowatt hour battery, is energy. Energy is equals to power into time. If you want to charge this vehicle in your house you have a power capacity of 2 kilowatts maximum in your house. If you charge your vehicle using 2 kilowatts power, how much time it takes to completely charge 40 kilowatt hour battery? Last one. The vehicle has 40 kilowatt hour battery. The vehicle is charged using 2 kilowatt hour charger in your house. How much time it takes to completely charge the vehicle? This side. And ఈ మీ 8 మెంబర్స్కి దీనికి ఆన్సర్ తెలుసు. మిమ్మల్ని కాదు 4th క్లాస్ వాళ్ళని అడిగినా కూడా ఆన్సర్ చెప్తారు. వాట్ ఐ ఎక్స్పెక్ట్ ఈస్ మీరు లాస్ట్లో కూర్చున్నారంటేనే జనరల్గా మేమంతా ఇన్వాల్వ్ కాము. వీఆర్ నాట్ ప్రోయాక్టివ్. వస్తాము, బాల్కనీలో కూర్చుంటాం, మూవీ నచ్చితే చూస్తాం, లేకపోతే పడుకుంటాం. These days, every engineering graduate must have certain skills. These skills are called 21st century employability skills. Critical thinking, problem solving nature, communication, collaboration, creativity, and under communication, collaboration, leadership also plays an important role. So the communication and collaboration plays an important role, along with creativity and critical thinking and problem solving nature. Under communication and collaboration, ఎంత ఎక్కువగా ఇన్వాల్వ్ అయ్యి, ఎంత డిస్కషన్స్లో పార్టిసిపేట్ చేసి, ఎంత ప్రొయాక్టివ్గా ఉంటే అలాంటి గ్రాడ్యుయేట్స్ ఇప్పుడు కావాలని కోరుకుంటున్నాం. We want to get better placement opportunities, better jobs. If you are here for a better career, don't ఫ్రంట్కి ఎప్పుడైనా సీట్ ఖాళీ ఉంటే సినిమాల్లోనే ఆ లాస్ట్ సీట్స్ బాల్కనీస్ ఖాళీ ఉన్నాయి. రిమైనింగ్ అన్ని ప్లేసెస్లో, క్రికెట్ మ్యాచ్లో కానీ, సర్కస్లో కానీ, లేకపోతే డ్రామాస్లో కానీ అన్ని ఫ్రంట్ సీట్సే ఖాళీ ఉన్నాయి. ఫ్రంట్ సీట్స్లో కూర్చొని అడగవచ్చు, ఫ్రంట్ సీట్లో కూర్చొని నిద్రపోవచ్చు. ఫ్రంట్ సీట్లో కూర్చొని కూడా నిద్రపోతున్నారంటే చెప్పేవాళ్ళు సరిగ్గా చెప్పట్లేదు. When years are passing, students not involving, and students are not asking the questions, are not following, not responding, which is not good for the student community. చెప్తే ఏమవుతుంది మహా అంటే తప్పు అవుతుంది, అక్కడి నుంచి ఏమవుతుంది. As long as you are a student, you have every right to commit mistakes, to say wrong answers. నేను తప్పు చెప్తే కొంచెం ఎంబరాసింగ్ ఉంటుంది. ఇక్కడ వచ్చి మైక్ పట్టుకొని చెప్తూ ఇక్కడ తప్పు చెప్పామనుకోండి బాగుంటుంది. స్టూడెంట్ ఏం తప్పు చెప్పొచ్చు కదా. హ్యావ్ ఎవరీ రైట్ టు కమిట్ మిస్టేక్స్. By learning, mistakes are common. But if you have that in mind and if you are not responding or if you are not involving, you cannot improve those things. అందుకే సరదాగా లాస్ట్ బెంచ్ అంటున్నారు కానీ I like this college, I like the students of this college. So how much time it takes? 20 hours. 40 kilowatt hour by 2 kilowatts. It takes 20 hours to charge. Can we wait for such long period? Older vehicles used to use 20 kilowatt hour batteries. 20 kilowatt hours by 2 kilowatts used to take 10 hours. Our vehicles for 10 hours overnight for electrical cars. And overnight how much energy can be stored in the batteries? 20 kilowatt hours. If 20 kilowatt hours, how much distance you can travel? As per Tata Nexon EV, 20 kilowatt hours 130. So it's about 150, 160. Four minutes on that. I'll just briefly introduce, because these things are not available in any of the textbooks and you don't see these things frequently. So just as most of you are teachers except those 8-9, you can grasp it and later you can collect and you can work it on it. I will give these PPTs in PDF format to you and you can go through it. Just I thought of sharing the concept to you so that you can work on it and you can teach the same to your students also. Any batteries or electric vehicles can be charged in 3 ways. One is conduction charging or conductive charging. Second one is inductive charging or wireless charging. Third one is battery stuffing. Conduction charging means connect the cable, charging cable, connect it, charging. So this is called conduction charging. Conduction charging can be classified into 3 types. One is level 1 charging, level 2 charging, level 3 charging or DC fast charging. Level 1 charging uses single phase 120 volts AC supply. Do you get 120 volts AC supply in India?
No, sir.
Where?
US.
In US we have 120 volts single phase AC supply. And if you have single phase 230 volts socket and if you connect this to vehicle and charge it, this level of charging is called level 1 charging. The maximum capacity of this level 1 charging is only 2 kilowatts. up to 2 kilowatts. Level 2 charging is 230 volts or 240 volts two phase in US or 230 volts single phase in India and Europe. If you connect 230 volts single phase supply, such type of charging level is called level 2 charge. Using level 2, you can charge a vehicle up to 20 kilowatts, 3 to 20 kilowatts maximum. Level 3 charging is DC fast charge. Here we don't use AC charger. AC is converted to DC externally using charging station. AC power is converted to DC power. DC power is supplied to the vehicle at higher rates, higher powers. This type of charging is called DC fast charge. The minimum power capacity starts from 50 kilowatts to 350 kilowatts. In India also we use fast charging stations. In India 10 kilowatt charging stations are also called fast chargers. Many fast charging stations in India use 10 kilowatts power. Very few 50 kilowatt charging stations are available at present, and as we have discussed in the morning, many new charging stations are coming up. More than 14 lakhs charging stations are going to be established by 2030. So many high power capacity charging stations are coming up. Level 3 charging is externally AC is converted to DC, and renewable energy will also be integrated. We will have other communication control setup, and the DC power supply is applied to electrical car at faster rates, minimum of 50 kilowatts power to 350 kilowatts power. If the Tata Nexon vehicle is connected to 350 kilowatts, how much time it takes? If 40 kilowatt hours battery is connected to 350 kilowatt hour charger, 350 kilowatts power charger.
Almost two. It takes minutes.
7-8 minutes.
Yes.
The Tata Nexon EV vehicle can be charged in 7-8 minutes, provided the battery supports this much C rate. How much is the C rate here? 350 by 40. Around 8. The battery technology must support that high C rate. The present day lithium ion batteries will not support. If Elon Musk and others produces the solid state batteries, if that solid state battery supports the C rate of 7 or 8, then these vehicles can be charged in 5-6 minutes. That is ultimate goal of charging as far as EVs are concerned. Remaining things that you can quickly go through it, you can easily understand. Now, every vehicle, every electrical vehicle will have an onboard charger, a small capacity onboard charger. What is the purpose of this onboard charger? If you plug this charger to your house power socket, 230 volt single phase or 3 phase 440 volts, this power charger inside the vehicle converts AC power to DC power, and the DC power is supplied to the battery for charging, but at low rates, 2 kilowatts, 3 kilowatts, maximum 4 kilowatts. If you want to have 10 kilowatt charger, 30 kilowatts charger inside the vehicle, the power electronic requirement increases. Power converter size increases. Cost of the onboard charger increases. If cost of the onboard charger increases, weight also, vehicle cost also increases. If vehicle cost increases, we may not purchase. That is the reason why onboard charger capacities are fixed to a particular capacity. 3 kilowatt, 4 kilowatt, like that. And if you want to charge with more than 3-4 kilowatts, we use external chargers. It uses onboard charger. AC power is connected to onboard charger. Onboard charger converts AC power to DC power and stores in the battery. If you want to charge at high powers, external onboard chargers are used. Onboard charger may be AC charger or DC charger. AC chargers up to 20 kilowatts and DC fast chargers from 50 kilowatts to 350 kilowatts. If external charger is AC charger, AC power is converted to DC power, then connected to battery. Or if the external power is a DC power, this internal onboard charger is bypassed. Directly this DC is connected to DC bus bar, DC bus to batteries. So onboard charger and off-board charger. Every vehicle will have a small capacity onboard charger. You can charge your vehicle at your home by connecting small power, or you can connect the vehicle to a charging station. You can charge the vehicle at higher power capacities. Last 2 minutes, sir. What are the main components of a charging station? A charging station consists of AC to DC power conversion. The DC power is applied to DC bus rails, then DC rails to an inverter to a motor drives the wheels. Then from DC rails to step down power converter, DC to DC converter, buck converter, then to electronic equipment, auxiliary equipment, power steering motor, windows, motors, etc. Then this side DC to DC converter to battery. And in case of regenerative braking, battery charges. Normally battery decharges. During charging, power flows in this way and to battery. What this must have inside the charging station, we have AC to DC rectifier, mostly diode bridge rectifier, and then filter. This DC can be connected directly here. If this DC power is directly connected here, any fault occurs in the grid, the fault carries to the motor and battery, damages the power converters, motors or batteries. Or any internal fault occurs inside the vehicle, that fault carries to the grid and it damages the equipment in the grid. There must be an electrical separation. There must be an isolation. So this DC power is converted to AC power using an inverter. AC isolation transformer is placed, and again AC power is converted to DC power, then filter, then this DC power is applied here. The charging station must have AC to DC rectifier and DC to AC inverter, isolated transformer, and then rectifier. As per IEC standards, galvanic isolation is mandatory for all the charging stations. If you purchase a two-wheeler through an online portal manufactured by China or any other company or substandard companies, if the vehicle is available at 20,000 rupees, 21,000 rupees, you import it and assemble it, connect the charger, it works well. If a fault happens, the fault carries to your vehicle will be damaged. Because low cost equipment will not have these isolation features and all. They compromise on these type of things. While purchasing vehicles, we need to check whether this is as per IEC standards or not. Levels of charging are level 1, level 2, level 3. And these charging connectors will have different modes in terms of communication and control point of view. If you plug the vehicle directly to, if you plug the power supply and current is connected to vehicle directly without any monitoring, controlling, without any battery management system, such mode of connection is called mode 1 of connection. In this case, we don't monitor charging process. Next one is mode 2, AC power supply through a control and communication. This control and communication monitors whether the power quality is good, what is happening like this. Still AC power supply is applied to vehicle. Mode 2. In mode 3, AC control and communication is not placed in the cable. This control and communication is placed inside the charging station. Different signals are sensed from the vehicle while charging the battery. What is the state of charge of the battery? What is temperature of the battery? What is the voltage of the battery? How much current it is taking? All these parameters are received. This cable consists of Positive, negative are phase neutrals. Along with those power lines, there will be communication lines also. This also. Through these communication lines, different signals are sent to the charging station. Inside the charging station, different algorithms are applied. Different external devices can also be interfaced, and the charging station controls the charging process. If you want to implement vehicle-to-grid technology, if power is available at a cheaper price, the communication controls and power will be transmitted to the vehicle. If grid demands more power, if they are in a position to buy the power from the vehicle can discharge, power can flow in opposite direction. If you want to implement such things, mode 3 configuration is required, or mode 4 configuration can be used to have fast charging. AC power is converted to DC power, DC power is connected to the vehicle. Or this can also be used to charge AC power and DC powers under mode 4. These days we use either mode 3 communication or mode 4 communication for our charging stations. These are different types of charging flex connectors we use. This flex uses phase 1, phase 2, phase 1 neutral 120 volts, phase 1, phase 2 240 volts in US, or in India single phase 230 volts can be connected between these two protective wire. We have two control pins. One is called proximity pin, another one is called control pilot. This proximity pilot ensures proper connection of the plug, whether proper connection is established or not. This control pilot controls charging current. What is at what current we want to charge, at what power capacity we want to charge. Power capacity voltage gives you current. If you want to allow 10 amperes, 20 amperes, how much current is actually flowing, compare actual current and difference current, use oscillator modulation, control the current. For this particular thing we use control pin. In Japan and US we use type 1 configuration, and in Europe we use type 2 configuration for 3 phase. This is for single phase, this is for 3 phase. China also uses similar type of configuration for 3 phase power. Pins are slightly slim when compared to it. And the same configuration is also used in India. In India also, type 1 configuration is used for the single phase power supply up to 20 kilowatts power. For 3 phase power supply we use type 2 configuration. In Europe, in China, in India also mostly we use type 2 configuration for AC charging stations. You find any charging stations, even fast charging stations also, if that is AC charging station, you find type 2 connection like this. Type 3 connection, this is an exclusive copyright product of Tesla. It appears, this look like a cat face, nice nose. For both the AC, same can be used, phase and neutral. For DC also same charger can be used. That is the specialty of Tesla charger. Positive and negative. And protecting the control pins. These days, DC fast chargers are common. DC fast chargers uses combined connection, combined connectors. This is AC pins we have discussed type 1. This is combined AC DC pin. This is called combo type 1 or CCS, combined charging system 1. CCS 1 or combo 1, which is combination of AC type 1 and DC pins. Positive. Type 2 with the DC, combo 2. And this is the Japan product. In US, Japan and Europe also it is more popular. Thank you. The charging, this connector name is Charge. Charge the mobility, the short form of charge the mobility in Japan. It supports more power. China has developed another product called GB by T as a charger. The last slide for information. This combined AC/DC charging station, CCS combined charging system, CCS1 supports up to 350 kilowatts. If the charging power level is from 50 kilowatts to 350 kilowatts, charging is called fast charging. It supports up to 350 kilowatts. Chademo from which company, which country? Japan. Has power capacity up to 400 kilowatts. Tesla from US. 2019 version 3 has 250 kilowatts power capacity. In 2019, I don't know what has happened in the last 2 years. I'll collect and update you. The latest type of connector is Chaozi. The third version of Chademo from Japan. Supports up to 900 kilowatts. If the Tata Nexon EV supports this, how much time it requires? Not even a minute. So these are different charging stations, charging speeds we have. I'll leave wireless charging with you. And future technologies are, we don't want to connect the chargers. And in cold countries, in European countries, and in Western world, they drive the vehicles at -30, -40 degrees centigrade. It's not possible to get down from the vehicle and connect the charger. There will not be any person to connect the chargers. Their vehicle owner must refill the vehicle also. So if the vehicle is brought to a particular location, at the bottom a charging coil is placed. It transmits electrical power. At the bottom of the vehicle, we place another receiving coil. The receiving coil receives the vehicle through a mutual induction. This is called inductive charge. If you operate these two cars at a very high frequency, we can establish a wireless charging. This type of wireless charging is called static wireless charging, where vehicle must be parked at a particular place. The efficiency of the charging is very less, and the distance between these two cars must be very small. Still, some countries are using this, and in India we don't have wireless charging for electric vehicles. For mobiles we have. We place mobile on a tray and it gets charged with low power devices. We may expect that by 2030 we may have this type of wireless charge. In the near future, what we expect? No, I don't want to wait at a particular place for charging. That too, it is a slow charging. While I am driving the vehicle on the expressway, the vehicle must be charged automatically. So at the bottom of the expressways, different transmission coils are placed. Coils will be placed. While you are driving the vehicle, the receiving coil receives the power from the transmission coil continuously, and your vehicle moves. If such road is erected from Jammu Kashmir, Srinagar to Kanyakumari, without any battery, without any storage, you can travel from the north to south without any battery charge, without any issue, and you can pay automatically from your account. For every kilometer, 10 rupees, 20 rupees will be deducted. So such charging schemes is called dynamic wireless charging scheme. Japan is erecting such type of road. 2 years back it started. Japan has already started this type of road. So last way of charging or refilling the electric vehicle is battery swapping. I don't want to wait 4 hours. I don't want to wait 20 hours. Still, beside our house, fast charger is available, 50 kilowatts power. If I charge with 50 kilowatts of power, my battery is getting damaged. What to do? Other solution is battery charging, like replacing our cooking cylinders, Bharat gas, Indian gas, whatever the gas we supply. What they do? Leave out with pipeline gas. They are also using pipeline gas for past 10-15 years. But before that, everyone of us have used cylinders now. So they want to refill our cylinder, they'll bring a new cylinder, connect the new cylinder and take away the old cylinder. Same thing is for batteries. Whenever you want to refill the battery, they'll take out the empty battery, they'll keep a new battery. This empty battery will be charged using slow charges for 20 hours. They'll have multiple chargers and all of those batteries can be placed in the godown, and overnight all these batteries get charged. And whenever you visit the charging stations, they'll take out the battery and place another battery. This is not a new technology. During 1900 itself, we got this technology, and one company has started this technology in 1900, 1905 in the US, continued up to 2014. They closed it in 2014. Not able to maintain last hopes on these electric vehicles. Our company closed అయినప్పటి నుంచి electric vehicles grow అవుతున్నాయి. Badly. And what is the drawback of this technology? గ్యాస్ సిలిండర్, మన ఇండియన్ గ్యాస్ సిలిండర్ మనది కాదు, అడ్వాన్స్ ఇచ్చుంటాం. మనకు మంచి సిలిండర్, పెయింటింగ్ బాగుండి, ఎర్రగా ఉండి, మన సిలిండర్ పట్టుకెళ్ళి చోట్ల పడ్డ సిలిండర్ పెడితే దాంట్లో సగం గ్యాస్ ఉన్నా పర్లేదు, సిలిండర్ మాత్రం చూడడానికి బాగుంటుంది. అది మళ్ళీ కప్పుడు లోపలేసి డోర్ వేస్తాం. So we accept such cylinders normally. So in batteries also, we may not accept replacing of our batteries. See, we feel that they purchased the vehicle very recently, our battery is very new, and that fellow is placing an old battery and taking away the new battery, and we may not permit. See, the company is also coming out. We are selling only vehicle, not the battery, and we are giving the batteries. Battery is our responsibility. If they give such type of assurance, we may prefer such things. Ola electric vehicles are doing that. Probably for the next year, they'll have these battery swapping technologies. That's all from battery charging point of view. I'll close the session here. Sorry, late by 20 minutes to accommodate. HOD garu 3 o'clock వరకే టైం ఇచ్చారు. Once again, take this opportunity to thank the principal of the Bhaskar sir and the coordinator of the workshop, FDP, good friend for past almost 10 years, Samsara garu. And I also take this opportunity to thank our friends. We are all colleagues working in different organizations. We know each other for the past many years. And కొంచెం ఎక్కువ టైం తీసుకున్న పేషెంట్గా విన్నందుకు థ్యాంక్ ఈచ్ వన్ ఆఫ్ యూ అండ్ థ్యాంక్ బ్యాక్ వెయిట్ చేస్తాం సార్. ఎక్కడ నిద్రపోకుండా 4 hours పారిపోకుండా ఎక్కడ. థ్యాంక్ యూ సో మచ్.
Thank
Thank you, sir. Your extensive knowledge and expertise in the field of electrical engineering and electric vehicles has inspired us also. On behalf of everyone here, I extend our heartfelt gratitude to you, sir.
Felicitation.
And also thank you for spending your valuable time for us, sir. Now I request our principal, Dr. C. Nagavaskar sir, and HOD, Dr. N. Samsira sir, to felicitate Dr. Venkat Reddy sir.
Normally in the house, what we expect, we don't expect any fast acceleration. We don't expect any fast movement of the devices. We use house backup power for lighting purpose, for fans purpose, for compressor purpose. Normally we don't connect our wash machine, we don't connect our fridge also. We use only for lighting purpose and fans purpose. For that, slow discharge is sufficient. Fast discharge is not required. Storage point of view, the lithium ion batteries stores huge amount of energy in a small container. Energy density is more. Power density is also more. For lead acid batteries, they are bulky in size.
Yes.
But in house, the weight is not an important aspect. For mobility, for electric vehicle, as the vehicle weight must be less, the battery based weight must also be very small. In house, where do you place your batteries?
Yes.
On the floor.
Yes, yes.
If it is 5 kilos more or 10 kilos more, it's not an issue. And once you get an opportunity, you try to lift the house lead acid batteries.
Yes, yes.
And initially you may feel that we can lift it with one hand, and later we realize we may not lift it with both the hands.
Yes, sir.
They are very solid things.
Yes.
So weight
Too
of
heavy.
the lead acid batteries are very
Too high, yes.
They are very cheap when compared to lithium ion batteries.
Thank you.
But cheaper price only we use lead acid batteries. We can also use lead acid batteries.
Lithium ion batteries. Yes.
Later, if the lithium ion batteries are used for vehicle for 6-7 years, after that those batteries may not be useful for vehicles. They cannot provide proper acceleration. Even you provide ultra capacitors also, they may not be useful for vehicles. Such type of batteries can be used for your inverter.
Yeah, home purpose.
Still then it can store 30% of the energy, 40% of the energy. It can supply, it can meet the expectations of your house. And such batteries can be connected in big numbers. They can be arranged in series and parallel. They can be used as battery energy storage systems also. Those batteries are called EOL batteries, end of life batteries. Still they can store 40% of the energy and they are not suitable for electric vehicles.
Thank you. Yes, sir. Thank you, sir.
Sir,
Thank
one more question. Sir, in the morning you told me that we have till then we have only 8,000 charging stations. In the future,
We don't have 8,000 also. 1,070, around 1,000.
Yeah.
1,070, 1,080.
And
In the near future we have.
near future we have.
At
we need to
present we have 10,000
14 lakh,
charging. 10,000
charging.
by 2030, 14
You
lakhs.
have created me curiosity to install a charging station. So what are the requirements or what are the parameters or procedure I need to install a charging station?
So, for electrical engineers, I request almost all of you to look at the charging stations. You must have a proper site, or you may take the site for a lease or for any other thing. Many companies are coming up, like Bharat Petroleum or HP or Indian Oil gases, petrol bunks are there. Similarly, Tata Power stations are there, and many companies are coming up. You may take a charging station from any company. Instead of fabricating your own equipment and getting the setting up the charging station, if you want to do this, you need to meet all the protocols, like what type of communication protocol needs to be established, what are the different norms we have. Instead of doing all these things, it's always easy to tie up with Tata Power or any such companies. Then you can apply for it through a national portal. You'll get the permission for the setting up of a charge.
Means like a franchisee, sir.
Like a franchise.
Franchise, okay.
Now, most of the petrol bunks,
Yes.
they will have Indian Oil petrol bunks or other petrol
Yes,
bunks.
yes.
It's not its own. It's
Yes,
a
yes.
franchise.
It's a
of
franchise,
Indian Oil.
yes.
It's always better to apply through Tata Power or any reputed. Adani is also there.
Yes.
Are you possible to apply direct application to companies or I need to go through government?
Yeah.
Through government, because government is providing lots of subsidies for charging stations also. At this particular point of time, only thing is we don't have many electric vehicles on roads, and when charging stations increases to 10 lakhs, proportionately electric vehicles must increase. Tomorrow, if any small incident happens, and if that is covered by all news channels, and we may not purchase electric vehicles for the next 10 years again. Let us hope that nothing will happen at this particular point of time. If number of charging stations increases and number of electric vehicles also increases, there will be a demand. Otherwise, you need to bear the losses for 2-3 years. It's always a better option to have a charging station along with a renewable power integration, solar power integration.
Thank you, sir. Thank you so much.